Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight, we're going on a gentle voyage, one that starts right where you are now, resting beneath the pull of gravity, perhaps wrapped in a blanket, the low hum of the world still around you, and slowly, softly, we'll rise. We'll lift off from Earth and drift, not in a rocket roar, but in quiet wonder, as we explore the vastness of the observable universe, from spacecraft and starlight to exoplanets and the faintest galaxies, all the way to the furthest reaches of what light allows us to see. And along the way, we'll ask a simple, haunting question: does the universe have a center? But we begin this slow ascent through space and thought. I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. In the lights, maybe turn on a fan for a soft background hum. Let your body relax, your shoulders settle, your breath ease. This isn't a journey you need to prepare for. There's no checklist, no boarding pass, just a willingness to let your thoughts drift upward, like the slow lift of a balloon on a windless day. Outside your window, whether the sky is dark or clouded or busy with city lights, the stars are there, quiet, patient, unmoving in our brief lifetimes, yet travelling through space at speeds we can scarcely imagine. They don't demand our attention, but when we really look, they offer something in return. Not answers, always, but a kind of calm perspective, an invitation to wonder. You might be lying on your side, with your hand tucked under your cheek, or curled like a comma, just waiting for rest to take hold. Wherever and however you find yourself tonight, you're at the perfect starting point, because this journey doesn't begin in a laboratory or an observatory. It begins in you, in your mind, your memory, your imagination. The universe doesn't ask for our permission to exist, it simply is, but it becomes something else entirely when we begin to notice it. When we pause to trace its outlines with soft thought, to ask not only what's out there, but what it means to be here. And maybe, in asking, we come a little closer to both. So tonight, as the clock ticks in the background, or doesn't, if you've wisely silenced it, we begin not with propulsion or mathematics, but with stillness. The same stillness ancient astronomers once felt, lying on desert stone, eyes fixed on patterns of light they didn't yet understand. We begin with breath, with quiet, with Earth beneath us and the universe waiting just above. Let's take this first step together. Do you remember the first time you looked up at the night sky and felt small? Not in a frightening way, but in that gently humbling way that makes you want to lie down and listen to the dark. Maybe it was during a childhood camping trip, when the tent zipper stuck and the stars spilled out like glitter across the canopy of night. Maybe it was during a blackout, when the usual distractions of streetlights and screens fell away, and for once the sky revealed what it had been holding all along. Or perhaps it was just now, just tonight, as you waited for sleep and found your thoughts slowly tilting upward. Space has a way of quieting things inside us. It doesn't shout or clamour. It doesn't demand our opinion or chase the latest trend. It just exists, vast and patient, indifferent to our schedules, our alarms, our inboxes. And yet, in that indifference, there is something comforting, something ancient. From an early age, many of us are drawn to space not because we understand it, but because we don't. The stars are there before we know what they are. The moon smiles down and we wave back. We picture ourselves in rocket ships made from cardboard boxes, helmets cobbled from mixing bowls, ready to drift into imagined galaxies just past the backyard fence. And somewhere inside, that imaginative stargazer often lingers. Long after we've learned about orbits and gravity and spectral lines, other fascinations of childhood, space doesn't fade. It deepens. As we grow, the sky doesn't become smaller. It grows more complex, more mysterious, We learn that stars are burning spheres of plasma, that galaxies number in the billions, that light itself has a limit, and still, it enchants us. The science doesn't spoil the magic, it enhances it. Because every scientific explanation is a door, not a wall. You learn that a rainbow is just light bending through raindrops, and then you learn that each raindrop contains a perfect little sphere of possibility. You learn that the stars are impossibly far away, and then you realize you're seeing them not as they are, but as they were, long before your great-grandparents were born. Light becomes memory, sky becomes story. And perhaps that's why space keeps us humble in the kindest way. It shows us that we are not the center of everything and never were, but it also reminds us that we are part of it, that in some distant future, someone might look up and see the faint glow of our sun, our galaxy, our breath of existence, and wonder, too. When astronauts first orbited Earth, many of them spoke not about the stars, but about the blue planet below, the thinness of the atmosphere, the swirling of clouds, the fragile skin of life in a vast ocean of dark. It wasn't the vastness that struck them, it was the delicacy, the unity, the realization that we're all nestled together on this one spinning sphere, trying our best. Gently in a chair, listening, imagining, floating, not through space, but through thought. That too is a kind of journey, and tonight we'll take it slowly, kindly, from the place you rest your head to the furthest starlight our instruments can detect. A journey not of engines and countdowns, but of wonder, of questions, of quiet amazement. There's no need to rush. We have all night, and the stars, as always, are in no hurry. If you stepped outside right now, barefoot on a cool patch of grass or leaning gently against a windowsill, and tilted your gaze upward, you might not see much. Perhaps a few dim stars if the city lights are kind, perhaps just clouds, moving slowly like thoughts across your mind, or maybe a deep, inky blackness that holds more than it reveals. And yet, even if the sky looks empty, it isn't. Even in the darkest night you are surrounded by motion, planets spinning quietly, galaxies rotating with the weight of stars, photons, little packets of light, crossing unimaginable distances just to flicker faintly against your retina. The cosmos is never still, and neither are you. Seizing now, as you lie there, Earth is turning. Gently, invisibly, but fast, about 1600 kilometers per hour at the equator, and as it spins, it's also orbiting the Sun at about 107,000 kilometers per hour. And the Sun, it's cruising through the Milky Way galaxy at roughly 828,000 kilometers per hour. All of this, and yet your tea doesn't spill, your book stays put, and your breath stays steady. It's easy to forget just how much motion we're cradled in. You might be tempted to think of space as out there, as something separate from us, something distant. But you're already in it, always have been. You're not on the edge of the universe, peering in like a tourist with a telescope. You're inside it, floating in the midst of it, made of it. The atoms in your body, your bones, your skin, even the thoughts drifting behind your eyes, were all once part of ancient stars. Stars that burned brightly, then collapsed, then scattered their contents into space. Those elements, forged in fire, drifted through the galaxy, mingled with dust and time, and eventually coalesced into a planet. And you, every bit of you is stardust, arranged with care and humming quietly with the echo of the cosmos. So when you look up at the night sky and feel a strange tug, like you're missing something you've never had, that's not foolishness, that's memory, deep memory, a resonance between what you are and what you came from. And tonight, we follow that thread. Not as scientists in a lab coat, although science will guide us. Not as explorers braving danger, although the distances will be vast. But as travellers of thought, curiosity, and imagination. Blackmail sights, the moon, the sun, the planets, and then drift into the dark beyond. We'll explore places we cannot touch, but can still imagine. Exoplanets orbiting strange suns, galaxies blooming like petals of light, the faint echo of the universe's beginning, still murmuring through space. And maybe as we move outward, layer by layer, the question will begin to form. Is there a center to all this? Is there some distant point around which everything spins, some cosmic heart? Or is the truth far stranger, that every point, everywhere, could be called the center, including the one you occupy right now? Take mind the question. It simply continues. But asking, that's where the beauty lies. So let's begin. Quietly, calmly. One breath. One thought. One star at a time. From here to the edge. There's a weight to being human. Not just the weight of worries or to-do lists, but the quiet, ever-present pressure of gravity itself. You've likely never noticed it much because you've never known anything else. It cradles you from the moment you're born. It's the gentle tug that holds your feet to the floor, the soft resistance in your arms when you lift a glass, the downward stretch you feel when you curl into bed. Gravity is invisible but never absent, a constant companion. It's easy to think of gravity as a burden, a force that pulls, restricts, drags things down. But there's something comforting in it too, isn't there? It's what makes your tea stay in the cup, your body stay in your chair. It's what lets rain fall, lets trees grow tall in defiance of it. Even sleep itself feels like a surrender to gravity, a yielding of your weight to the bed beneath you, a trust fall into the earth's embrace. But what happens when we let it go? That's the quiet quest, because to leave Earth is not just to travel somewhere new, it's to part with something deeply familiar, to let go of the one force that has held us every moment of our lives. Forbes who went into space didn't just float, they fell. They were caught in a continuous fall, a graceful orbit around the Earth where the pull of gravity was still present, but no longer felt in quite the same way. Inside a spacecraft, astronauts don't feel weight because they're falling with the ship. The floor no longer pushes back. There is no up, no down, only forward motion and the quiet drifting of limbs. Is to experience something that no human ever evolved to feel. Weightlessness. And yet, even that term is a bit misleading, because gravity is never truly gone. It's just different. It's still there, keeping the moon in orbit, drawing satellites along curved paths, guiding space stations around our planet like silent chaperones. Proximity those vessels, it feels as if the tether has been cut. Linebacker, think it. You push off gently from one wall and you keep going, slowly, silently, until another surface catches you. Your hair floats upward, your muscles relax in strange ways. There is no pressure on your feet, no familiar ground beneath you. You are held, not by floorboards or mattresses, but by motion, by trajectory, by the slow dance of orbital physics. To let go of gravity, even briefly, is to learn what you've always leaned against. You begin to notice how much of your daily life is shaped by that quiet pull. Eating, walking, sleeping, everything becomes a new puzzle in space. You must relearn movement, relearn rest. And yet, in this strange environment, something else emerges. A kind of lightness, not just of the body, but of the mind, a sense of play, of possibility. Astronauts have described it as dreamlike, as peaceful, as deeply quiet. Wonder that when they return, they often describe Earth not just as a place, but as a feeling of being held. Tonight, as we prepare to drift further outward, think about that force holding you now. The bed beneath you, the gentle pull downward. It is not a prison, it is a connection. A reminder that even as we explore the stars, our journey begins with a single truth. We are, and always have been, held by gravity. And only by feeling that pull can we begin to understand what it means to let go. It's tempting to picture space travel as sudden, as if we leapt into the cosmos with one bold bound. But the truth, like most human stories, is slower, more tentative, less of a leap and more of a long, cautious climb. The idea of escaping Earth's grasp has haunted our stories for centuries. Long before rockets, before physics, before combustion, people looked up and wondered, what if we could fly? What if we could leave altogether? In ancient China, fireworks cracked against the night sky, bright, brief sparks that marked the beginning of our fascination with upward motion. These early rockets weren't designed for space, of course, but they carried something even more powerful: imagination. Conject forward to the 20th century, and imagination found its engineers. A Russian named Konstantin Tsiolkovsky gave us the first real mathematics of rocketry. He famously said, "The Earth is the cradle of humanity, but one cannot live in the cradle forever." A poetic thought wrapped in fuel and formulas. Then came Robert Goddard in the United States, quietly launching the first liquid-fueled rocket in a snowy Massachusetts field in 1926. It rose just 41 feet, not exactly an interstellar journey, but a beginning. And then, slowly, the climb continued. By the 1940s and 50s, rockets became more powerful, first as tools of war, then as instruments of curiosity. The Cold War may have pushed the space race, but beneath the rivalry was something universal, the desire to touch the stars. In 1957, the Soviet Union launched Sputnik, a polished metal sphere no bigger than a beach ball. It didn't carry a camera or a crew, just a steady beep. But that beep travelled around the world, and in its rhythm was a message. We are no longer bound to the ground. 4 years later, a man followed. Yuri Gagarin, a young cosmonaut with a round face and a quiet smile, became the first human to orbit Earth. He circled the globe in just 108 minutes. When he returned, he simply said, "I see Earth. It is beautiful." That moment, brief, weightless, unbelievable, marked a new chapter for us all. On the other side of the world, the United States followed quickly. Mercury, Gemini, Apollo, each program a stepping stone. Each launch a careful negotiation between risk and resolve. The Saturn V rocket, the one that carried humans to the moon, was as tall as a 36-story building and burned with a roar that could be felt in the bones. And yet, for all its might, it was still built to do something very quiet, to carry people gently beyond gravity. But not all steps led outward. After Apollo, we turned our gaze closer to home. The space shuttle, with its wings and reusable form, became a symbol of repeated ascent. Like a flying school bus, it ferried astronauts and satellites for decades, building a new kind of space presence, one that was no longer just about reaching space, but staying there. Each rocket launch, from Vostok to Falcon 9, history. Stories of silent countdowns, shaking ground, held breath and fire against sky. But despite the drama of ignition and flight, the motion itself is subtle. To orbit Earth, you don't need to go up so much as you need to go fast. Over 28,000 kilometers per hour, sideways. Fast enough that as Earth pulls you down, you're already falling around it. A continuous curve, a quiet dance between gravity and momentum. So when you imagine the first step into space, don't think of it as a jump. Think of it as a long, careful stretch. From ideas to blueprints, from fuel to fire, from dreams to data. And behind it all, a quiet desire to look back at our home and see it from above. Contingency blue dot, still spinning, still holding us, even as we begin to drift away. If the moon was our first footprint in the cosmos, then the International Space Station is our first home. It doesn't look like much from Earth. Sometimes you can catch it streaking silently overhead, a bright dot gliding across the night sky in just a few minutes. No blinking lights, no engine sounds, just a moving star, passing over rooftops and oceans, continents and cloud banks. But, up close, the ISS is a marvel of quiet cooperation. A floating laboratory, a shared outpost, and a strange sort of house, all rolled into one. It's been circling our planet since 1998, orbiting at about 400 kilometers above sea level, travelling at over 28,000 kilometers per hour. And yet, inside, time seems to move a little differently. The ISS equal parts science and routine. There are experiments to conduct, on plants, on flames, on the human body. There are reports to file, emails to answer, even the occasional live broadcast to classrooms back on Earth. But there's also laundry that doesn't get done because there's no washer, meals that come in pouches, and socks that float away if you're not careful. There's no up or down on the station. The walls, the ceiling, the floor, they're all arbitrary. Astronauts orient themselves based on screens, labels, and a shared agreement about which way is forward. You could eat dinner with your head upside down and sleep strapped to the wall like a bat, and no one would blink. In fact, sleeping in space is one of the most quietly strange things you can do. There's no bed to lie on, no mattress to sink into. Instead, astronauts tuck into sleeping bags attached to the wall, zip themselves in and drift, held only by their own breath and a few Velcro loops. 2 has its own choreography. Without gravity, crumbs float. So bread is swapped out for tortillas. Soup becomes a sealed pouch, sipped through a straw. Coffee comes in vacuum-packed foil with a nozzle. Every meal is both a necessity and a little performance. One wrong move and your meatball might end up on the ceiling. But despite these peculiarities, the ISS feels surprisingly human. There are jokes, there are birthday celebrations, photos of loved ones taped near sleeping stations, a guitar floating in the corner. And then there's the view. The cupola, the space station's windowed observatory, offers one of the most extraordinary perspectives ever granted to a human being. Through its 7 panes of glass, astronauts can watch Earth scroll beneath them in silence. City lights flicker at night, lightning pulses in storms below. Oceans fade from deep blue to turquoise near the coasts. And every 90 minutes, they see a sunrise or a sunset. 16 of each, every day. It's here, in this strange floating home, that many astronauts begin to feel something new. Not just a sense of distance, but of unity. They speak of the overview effect, a sudden shift in awareness when seeing the planet from above. Borders vanish. Conflict seems small. The fragility of Earth becomes overwhelming. And yet, so does its beauty. You might be lying in bed right now, the roof of your house overhead, but just 400 kilometers beyond that is another kind of shelter. One that orbits silently, held up by motion, kept alive by teamwork, and filled with people who still brush their teeth, joke over breakfast, and look out the window just like you. Space Station isn't just a machine. It's a whisper that we can live, even if only temporarily, beyond Earth. Not in conquest, but in care, in collaboration, in curiosity. And that whisper, growing louder with each orbit, tells us something simple and powerful. We are capable of floating together. In space, everything floats. Your arms, your dinner, your socks, your toothbrush. Even your sense of direction loosens its grip. Life in microgravity is like stepping into a world where the usual rules of motion have been gently rewritten, and each movement is a question. What happens if I let go? At first, it's disorienting. Astronauts describe the first few days in orbit as a strange mix of awe and adaptation. Your inner ear, trained for a world where down always means floor, suddenly loses its anchor. You may feel dizzy, off balance, or slightly queasy. They call it space adaptation syndrome, but really it's just your body saying, wait a second, what happened to gravity? You adjust. You learn to push off surfaces with gentle taps, to drift instead of walk, to curl up instead of lie down. Movements become smoother, more intentional. It's not a place where you can rush. If you try, you might just spin slowly into a cupboard door. Less tasks become new adventures. Brushing your teeth, for example. There's no sink. You squeeze out a blob of edible toothpaste, scrub with your floating brush, and then either swallow the foam or spit it into a tissue. It's less glamorous than it sounds, but far more memorable. Showering, not really an option. There's no shower stall, no flowing water. Instead, astronauts use rinseless wipes and no-rinse shampoo. Washing becomes a slow ritual, a dance of droplets, cloth, and patience. Every drop of water is precious, reclaimed, recycled, reused. The humidity from your breath, your sweat, it's all captured, filtered, and turned back into drinking water. In a sense, the cup of tea you drink in the morning might include the very breath you exhaled the night before. There's food. Eating in microgravity is part science, part choreography, and part comedy. Because gravity isn't pulling anything down, crumbs float. Liquids form into shimmering spheres that wobble and drift like jellyfish. A spoonful of soup can become a small, wandering satellite, unless it's handled carefully. That's why tortillas are so beloved on the station. Unlike bread, they don't crumble. You can spread peanut butter on one, roll it up, and take a bite without worrying that rogue crumbs will clog an air filter. Meals are pre-packaged and heat-sealed. You warm them in a small oven, really just a metal box with elastic straps, and snip them open with scissors. You eat using a fork or spoon, velcroed to your tray, because otherwise you'd spend more time chasing your cutlery than your food. And then, of course, there's the bathroom, the space toilet, perhaps the most feared and revered appliance aboard any spacecraft. Without gravity, waste doesn't fall, it floats. So suction takes the place of gravity. The toilet uses fans to draw everything, solids, liquids and pride, into the proper containers. It takes practice. Astronauts train for it. And there's a checklist, of course. Lining up properly, making sure the airflow is working. And, when it's over, sealing everything with care. Nothing is flushed. Everything is stored. Even urine is filtered and processed into, yes, more drinking water. It's not as unsettling as it sounds. In fact, it's a marvel of engineering and sustainability. On Earth, we call it recycling. In space, it's survival. Despite the awkwardness, there's a quiet beauty to all of it, a gentleness, a sense of living lightly, of learning to exist without leaving a mess behind. Everything you use must be accounted for. Every motion is mindful. You become acutely aware of how much waste a single human can produce and how elegantly it can be managed, with care and intention. So next time you brush your teeth, or sip your tea, or flush your toilet without thinking, take a moment. Somewhere above you, someone is doing the same thing, in a small floating home where every drop floats, every movement glides, and nothing, not even the ordinary, is taken for granted. In microgravity, even the mundane becomes miraculous. There's a window in the sky, a quiet chamber of glass and metal, suspended 400 kilometers above the surface of Earth. It's called the cupola. From the outside, it looks like a small dome, almost unremarkable, just another module on the International Space Station. But from the inside, it's a cathedral of perspective. 7 windows arranged like the petals of a mechanical flower, opening not to stained glass or distant hills, but to an entire planet, softly turning. Plasmonauts drift into the cupola to take photos, to check on approaching spacecraft, to perform technical tasks. But often they come simply to look, to press their helmets against the glass and float in silence, to watch their home from a vantage point most of us will never reach. From up there, Earth isn't a globe. It's not a sphere on a classroom desk or a blue marble in a textbook. It's alive, breathing, in motion. The clouds ripple and coil like cream in coffee. Storms swirl with quiet force. Mountain ranges stretch like ancient scars. Rivers wind like silver threads. And everywhere, life. City lights blink across the continents. Ships move slowly across dark seas. The pale green of forests. The golden sweep of deserts. The endless shimmer of ocean, sometimes deep sapphire, sometimes pale jade, and sometimes, in rare moments, you might see the curve of an aurora, flowing like a curtain of emerald fire, dancing in the charged breath of solar winds. And then there are the sunrises. The station orbits Earth roughly every 90 minutes, which means astronauts witness 16 sunrises and 16 sunsets each day. But it never gets old. Imagine watching the first line of gold cut across the edge of the planet, a slow burn, blooming into colour as the atmosphere ignites in pinks, oranges and soft blues. The horizon isn't a flat line, it's a glowing curve, bending gently around the shape of a world. That curve is important. It's what gives the Earth its feeling of delicacy. From this height, the atmosphere looks impossibly thin, just a faint halo of blue, a film, a whisper. It's all that stands between life and the cold silence of space. The station, even in all its complexity, floats above that line. Earth is below, cocooned in light and air. The station is beyond it, drifting just slightly outside the warmth of home. And yet, that distance offers clarity. It strips away politics, boundaries, and noise. From above, there are no nations, no borders, just one glowing orb turning slowly in the dark. Astronauts speak of something called the overview effect, a shift in awareness, a sudden, deep understanding that Earth is not a collection of separate places, but one interconnected system, a single, fragile habitat shared by all. It's not a scientific discovery, it's a feeling, a quiet awe, a reverence, a softness. You don't need to go to space to feel it, though. Sometimes, all it takes is a photo, a video, a memory, or simply the knowledge that it's above you right now, turning gently, endlessly. Our pale blue dot, as Carl Sagan once called it, suspended in a sunbeam. Tonight, as you lie still, maybe you can picture it, the station orbiting overhead, the cupola filled with silence. A figure floating gently gazing out the window, watching the planet glide beneath like a dream you never want to wake from. And perhaps, just for a moment, you can feel that curve, that atmosphere, that turning light, and know this is home. Beautiful, fragile, and shared. There's a change that happens when you leave Earth, not just to your body, but to your mind. It doesn't arrive all at once. It builds slowly, quietly. Like waking up from a dream only to realise the dream was the world you left behind. Astronauts don't always expect it. They train for the launch, for the science, for the weightlessness and checklists and contingency procedures. They learn how to handle emergencies, how to dock a capsule, how to fix a broken valve. But few are truly prepared for what happens when they look back and see Earth whole. It's not just beautiful, it's different, more delicate, more alive, more solitary. Edgar Mitchell, one of the Apollo astronauts, described it as a sudden feeling of unity. You develop an instant global consciousness, he said, a people orientation, an intense dissatisfaction with the state of the world, and a compulsion to do something about it. Others describe tears, speechlessness, or a quiet, unnameable ache, something between wonder and mourning. From orbit, Earth doesn't look like a planet filled with conflict or clutter. It looks serene. Clouds pass without judgment. Oceans don't recognise flags. The thin blue line of atmosphere hugs the surface like a protective whisper. And the whole thing, this spinning marble of colour and movement, seems improbably small. Vulnerable, even. You change something inside. That's what they all say. It softens you, reorients your perspective. You realise that the maps we draw, the borders we defend, the ideas we divide ourselves by, none of them are visible from space. What is visible is a planet alive with patterns, storms blooming like flowers over oceans, lightning flickering like thought, wildfires trailing smoke like ribbons in the wind. Beauty and fragility together. Even astronauts who return to Earth, who step again into gravity and routine, often speak of that view as something they carry forever. It's not just a memory, it's a lens. It colours the way they see everything: grocery stores, headlines, politics, rivers, their own breath. All part of one interwoven living system. It's a perspective that doesn't require a rocket, though. You can feel it, too. Sometimes all it takes is a moment of stillness, a clear night, a quiet hillside, or even a photograph from a space probe. Something that reminds you that you're not outside the universe looking in. You're inside it, moving with it, made of it. Unleashed, you're on a planet that spins through space, warmed by a star, surrounded by other worlds, and above you, right now, there are people floating in a house that orbits the globe, held in place not by magic, but by the simple balance of motion and gravity. And they, too, look back and wonder. That feeling of connection, of awe, of quiet belonging, that's the beginning of a cosmic perspective. It doesn't give you all the answers. It doesn't explain every mystery, but it offers something just as powerful. The invitation to keep looking, gently, curiously, without fear. And tonight, that's what we're doing. Following the path of that perspective, step by step, through the solar system and beyond. Not to escape Earth, but to understand it. Not to leave home, but to see it more clearly. So now, with gravity behind us, and the curve of Earth fading into shadow, we begin the next part of our journey. Outward. Always outward. The moon is our nearest neighbour, and yet it still feels impossibly far. You can see it from your backyard, glowing softly, pulling at the oceans, lighting up quiet streets. It rises, it sets, sometimes full, sometimes slivered, always there, a familiar face in the sky. But for all its constancy, it's also a world of silence. No wind, no water, just dust, rock, and long, unbroken shadows. The first time humans stood on its surface, they left behind more than just footprints. They left silence, a kind of sacred hush. Because there, with the earth hanging above like a blue marble in the blackness, they realized just how far they'd come, and how alone they were. When Neil Armstrong stepped onto the moon in 1969, his words were broadcast to millions. That's one small step for man, one giant leap for mankind. But the sound of his boot pressing into the lunar soil made no noise at all. There's no air to carry sound, just powdery regolith, crushed by time and meteorites, welcoming its first visitor in 4 billion years. That soil holds secrets. It tells a story of impacts, of cosmic collisions, of quiet formation. It clings to everything. Astronaut suits, boots, gloves, like fine charcoal. It's sharp too, not worn smooth by water or wind. And it smells, they say, faintly like gunpowder when it enters the spacecraft. A dry, metallic scent stirred by alien chemistry. The moon doesn't have weather, but it does have extremes. In sunlight, the surface can reach over 120 degrees Celsius. In darkness, it plummets to minus 130. And because there's no atmosphere to scatter light, the shadows are sharp and absolute. Step into one, and you're surrounded by pure blackness. Step out, and the sunlight is so bright it's almost blinding. A landscape of contrasts, with no in-between. And yet, it's beautiful. Stark, yes. Bleak, maybe, but beautiful. The horizon is close, just a few kilometers away because the moon is small. The sky is pitch black, even at midday. And overhead, the earth shines, 4 times bigger than the moon, looks from here. It doesn't twinkle, it just glows, full of clouds, blues and greens, spinning gently in place. The Apollo missions only explored tiny patches of this world. 6 landings, 12 astronauts, a few flags, a few rovers, some science experiments, and footprints that still remain, undisturbed. No wind to erase them, no rain to soften the edges, just time, ticking quietly. Since then, we haven't returned. Not yet. But plans are forming again. Robots have scouted new regions. Orbiters have mapped frozen craters at the poles, places that never see sunlight and may hold ancient ice, water. The possibility of staying longer, of calling the moon not just a destination, but a base. And why do we keep looking back? Why does it still pull at our imagination? Playoffs, because it was our first step into the beyond, our first moment of being there, gone farther. And it reminded us that even in silence, even in a vacuum, wonder finds a way to echo. Perpendicular, as you drift towards sleep, picture those slow, bouncing footsteps, the crackle of radio in the silence, the long shadows cast by a single astronaut, the earth above, suspended like a dream, and the moon beneath, quiet, patient, waiting. As we drift gently outward from Earth and its moon, the next stops in our solar journey are the inner planets, our rocky cousins in orbit around the Sun. These are the terrestrial worlds: Mercury, Venus, Earth, and Mars, all made of rock and metal, all shaped by time and violence, and all astonishingly different from one another. Let's begin with the closest, Mercury. It's the smallest of the 4, not much bigger than our moon, and it hugs the Sun like a moth to flame. From its surface, the Sun appears more than 3 times larger than it does from Earth. There's no atmosphere to protect or soften, no clouds, no wind, no sky-blue dome, just an endless black sky and a cratered surface baked by sunlight. During the day, temperatures soar to 430 degrees Celsius, but at night, without an atmosphere to trap warmth, it plummets to minus 180 degrees Celsius. A world of harsh extremes where sunrise and sunset stretch on for hours, and a single Mercurian day lasts longer than its year. Fiberglass its nearness to the Sun, Mercury is oddly quiet, no volcanoes, no weather systems, just ancient rock, scarred by billions of years of impacts. And yet, it's not lifeless in every sense. Recent missions have found hints of frozen water in deep, shadowed craters near its poles. Even here, so close to the fire, there are pockets of cold where the sun never reaches. The planet named for the goddess of beauty, and, from afar, it certainly lives up to the name. Its thick atmosphere reflects sunlight so well that it shines brightly in our sky, often mistaken for a star. But beneath those clouds is a different story. Pursuits is not serene, it's seething. The surface is hotter than Mercury's, even though it's farther from the sun, over 460 degrees Celsius, hot enough to melt lead. Why? Because its thick atmosphere is made almost entirely of carbon dioxide, a runaway greenhouse effect gone to its most dramatic extreme. The clouds aren't fluffy and white, they're thick with sulfuric acid. The pressure at the surface is crushing, equivalent to being nearly a kilometre underwater on Earth. And yet, Venus once might have been different. Some scientists believe it could have had oceans, maybe even been Earth-like, long ago. But something changed, a tipping point, a runaway process. And now, it's a lesson in what happens when a planet traps too much heat, too fast. A mirror we rarely want to look into, but maybe should. And finally, the red one, Mars. So familiar in our imaginations, so inviting. Cold, dusty and rust-coloured, its surface tells a quiet story of loss. Because Mars, too, may once have been warm and wet. There are dried riverbeds winding like veins across its surface, canyon systems longer than entire countries, ice caps at its poles, traces of ancient lakes and perhaps even seas. But now, Mars is quiet. Its atmosphere is sine largcium, once degree. It's not different the cloud and lakes. The square is a harem as we neat it in like all Earthists to get the rule in Baitenia. Because Mars is a different, its clouds to get the rule in mighty Rilion there. The 18 Lake Teen, Walt cars roam in iron-rich dust. Still, it has seasons, it has weather, it has morning frost and dust devils, and the occasional pale sunset tinged with blue. Each of these planets, Mercury, Venus, Mars, offers a reflection of something possible, a world too close to the sun, a world that overheated, a world that cooled and dried, and in the middle Earth, balanced for now. Tonight, as you rest, you are lying not just on a planet, but within a family of worlds, some scorched, some frozen, some mysterious, each one turning, orbiting, lit by the same star. The inner solar system is a dance of stone and silence, and you are part of its rhythm. Mars is many things, a desert, a mystery, a memory of what might have been, but for now, it is most of all a place we've visited with our machines. We've never walked its surface, not yet. No boot prints dot its red dust, no human hands have touched its rocks, but still we've been there. We've sent explorers, quiet, tireless, solar-powered travellers, to roll, dig, sniff, photograph and listen. Robots, rovers, our mechanical proxies. The first successful visitor was Viking 1 in 1976, a lander that touched down softly, unfolded its instruments, and sent back images of a barren, rock-strewn landscape. It didn't look like much. No alien cities, no waving Martians, just rust-coloured stones and a thin atmosphere hazed with dust. But to the scientists who received those first photographs, it was like looking at the surface of another dream. This was not theory, this was contact. Disregave sent many others, Spirit and Opportunity. Twin rovers launched in 2003 were designed to last just 90 days. Spirit explored for over 6 years. Opportunity kept going for nearly 15. Their wheels left gentle tracks across ancient plains. Their robotic arms reached out to taste the dust. They found hematite, blueberries, scientists called them, evidence of water long gone. They weathered dust storms, temperature swings, and silence. When Opportunity's mission finally ended after a fierce Martian storm, NASA's last message to it was simple: "Thank you, stay safe." And the rover's final transmission was haunting: "My battery is low and it's getting dark." Unfinished. Then came Curiosity, larger and more ambitious. It landed in 2012 using an absurdly daring method called the Sky Crane, where rockets hovered briefly in place to lower the rover gently on cables. It worked. Curiosity still roams the Gale crater today, studying rock layers like a planetary historian reading chapters of the past. Jailed a drill, a laser, and even a weather station, it's found clay minerals and methane spikes, measured radiation, and helped confirm that Mars was once habitable, though whether it ever hosted life is still unanswered. It takes selfies too, not for vanity, but for calibration, and yet there's something oddly endearing about seeing this dusty little explorer standing alone on another world, smiling with its own arm. Turbulence. There's Perseverance, a new generation of explorer. It landed in 2021 in Jezero Crater, a place once home to an ancient river delta. Perseverance carries with it more than just instruments. It carries questions. And it carries Ingenuity, a tiny helicopter, the first ever to fly on another planet. Bufferingi was a test, a simple proof of concept. It wasn't expected to last more than a handful of flights, but like its rover cousins, it exceeded expectations. It flew, again and again, skipping across thin air, 225 million kilometers from Earth. A buzzing, dragonfly-sized scout on a silent red plane. These machines aren't just tools, they're stories. Each rover carries with it a piece of human hope, determination, and creativity. They have no thoughts, no feelings, and yet we name them. We mourn them. We speak of them as companions, because they go where we cannot, yet. And perhaps one day, the tire tracks left behind will be joined by footprints. Perhaps a human voice will echo softly in the Martian wind. Perhaps we'll build something lasting there, but even if we never do, we've already left a mark. Not just in dust, but in memory. On your own rocky world, Perseverance is still awake. Somewhere on a frozen plain, beneath a salmon-coloured sky, it moves slowly forward. Camera blinking, arm extended. Listening, digging, dreaming. For now, it is enough. Between the orbits of Mars and Jupiter lies a quieter region of the solar system. Not silent exactly, but slower, dimmer. A space filled with ancient things, broken pieces, lonely travellers, fragments of a story never finished. This is the asteroid belt. Despite how movies might show it, the asteroid belt isn't a chaotic field of tumbling boulders smashing into one another. In truth, it's mostly empty space. The asteroids are scattered, often millions of kilometres apart. You could fly through the belt 1,000 times and never see one up close. But they're there. Millions of them. Each one drifting along its own path, following the quiet rhythm of gravity and inertia, peps and sizes. Some are no bigger than pebbles. Others, like Ceres and Vesta, are hundreds of kilometres across. Ceres is even classified as a dwarf planet, a round, icy body with a hint of geology beneath its surface. In 2015, NASA's Dawn spacecraft entered orbit around it, becoming the first probe to visit a dwarf planet. There, it found strange white patches of salt, perhaps remnants of ancient briny water that once bubbled up from below. Asteroids are more than just rocks. They're leftovers, relics from the formation of the solar system, material that never coalesced into a planet. Jupiter's gravity kept them from joining. Too much pull, too much motion. So instead of becoming something larger, they stayed scattered, unfinished, waiting. Some are made mostly of metal, nickel and iron, dense and dark. Others are carbon-rich, with long, organic molecules, the raw ingredients for life. Still others are stony, pockmarked with craters cracked by collisions. Each one tells a story of impacts and silence, of orbits shaped by ancient forces. Popcorn, they leave the belt. Priesthoodly, a nudge, a gravitational handshake with Jupiter, a collision, a quiet spiral of decay sends an asteroid inward, toward the inner solar system, toward us. That's where meteorites come from, fragments of asteroids that find their way to Earth. Most burn up in the atmosphere, painting streaks of light we call shooting stars. But some survive, and when they land, they bring messages. Bursting winds are older than Earth itself. Some contain amino acids, complex organic compounds formed without biology. Some contain minerals formed in the presence of water. They are postcards from a time before time. In this way, the asteroid belt is not just a graveyard. It's a library, a museum, a bridge between the planets and the past. Before we're not done with it yet. NASA's Lucy mission is currently on its way to study Trojan asteroids, ancient bodies caught in Jupiter's orbit, and Psyche, Another mission aims to visit a metal-rich asteroid of the same name, perhaps the exposed core of a failed planet. If so, it may give us a glimpse at what lies beneath Earth's surface, something we can never reach directly. Minimize to the belt, Attillness to the belt, patience. These rocks have waited billions of years, watching planets form, collide, settle, watching Earth bloom with oceans and trees and cities, watching from afar. Tonight, while you drift towards sleep, they drift too, quiet, steady, unchanging. Not because they're lost, but because they were left behind. And sometimes, what's left behind holds the oldest truths of all. Beyond the asteroid belt, the solar system changes. The rocky planets give way to giants, worlds without solid ground, vast and swirling, each one wrapped in storms and secrets. These are the gas giants, Jupiter and Saturn, followed further out by their ice giant cousins, Uranus and Neptune. Together they hold most of the solar system's planetary mass, and yet we've never stood on them. We never could, because these worlds don't have surfaces in the way Earth does. There's no place to land, no firm crust beneath your feet, just layers of gas that deepen and compress until they become something neither quite gas nor quite liquid. A strange state shaped by immense pressure. If you fell into Jupiter, you'd pass through clouds, then denser clouds, then darker, hotter depths, until even light couldn't follow. But from afar, they are breathtaking. Jest of them all, a striped, fast-spinning colossus. Its storms are legendary. The Great Red Spot, a swirling vortex larger than Earth, has raged for centuries. It changes colour, it shifts shape, but it persists, like a thought you can't quite let go. Jupiter's atmosphere is layered in creams and oranges, bands of rising and falling gases that flow in opposite directions, creating patterns of unimaginable scale. Southeastern lightning flashes in its clouds, brighter than anything seen on Earth. Beneath the atmosphere, hydrogen is compressed into a metallic form, electrically conductive, strange and hidden, and surrounding the planet is a powerful magnetic field, far stronger than Earth's, capable of trapping radiation in deadly belts. Yet even in its violence there is grace. Its moons, more than 90 of them, spin around it like a miniature solar system. Saturn, next in line, is softer in hue, pale gold, muted browns, hints of grey. But what draws the eye are its rings, wide, delicate, almost impossibly thin. They stretch out for hundreds of thousands of kilometres, made mostly of ice, some pieces no bigger than pebbles, others the size of houses. No one knows exactly how they formed. Were they the remains of a shattered moon, or a leftover from the planet's birth? Either way, they are fleeting. The rings may one day vanish, pulled slowly into Saturn itself. Xiaomi has storms too, including a strange, persistent one at its north pole, a hexagon, a six-sided jet stream, stable and strange, unlike anything else in the solar system. It doesn't make sense, and yet it persists, whirling quietly in its cold, upper atmosphere. Giants, Uranus and Neptune, blue and distant, often forgotten but no less remarkable. Uranus spins on its side, tipped over like a fallen marble. Its axis is tilted more than 90 degrees, so its seasons are unlike anything else. Each pole spends decades in sunlight, then darkness. Its pale cyan colour comes from methane in its atmosphere, absorbing red light and scattering blue. Beneath the clouds may be a slushy ice interior, ammonia, water and methane under pressure. Neptune, farthest of all, is a deep, rich blue, darker than Uranus, mysterious and turbulent. Despite its distance from the Sun, Neptune hosts the fastest winds in the solar system, over 2,000 kilometers per hour. It has storms too, giant dark patches that appear and vanish. And one small moon, Triton, orbits it backward, against the planet's rotation, a clue that it may be a captured object, a stranger pulled into its orbit long ago. Outer worlds are not lifeless. They are active, dynamic, ever-changing. Their storms, their winds, their shifting atmospheres, they all remind us that motion does not require land, and life is not the only measure of mystery. Tonight, as you rest, these giants continue their long orbits. Their clouds still swirl, their rings still gleam, and the wind, though no one hears it, still sings through their endless skies. Deep cold beyond Mars, where sunlight fades and planets swell into giants, some of the most intriguing places in the solar system aren't planets at all. They're moons, quiet companions orbiting the larger worlds, each with its own secrets. Some are icy, some are active, and some may even be alive in ways we're only beginning to imagine. Start with Europa, one of Jupiter's many moons. From above it looks like a cracked eggshell, smooth, bright, streaked with long dark fractures. Its surface is made of water ice, so cold and hard it creaks like ancient glass. But beneath that shell, something stirs. A hidden ocean, salty and vast, warmed by the slow kneading of Jupiter's gravity. Tides rise and fall inside this moon, not with water rushing up beaches, but with entire layers of ice flexing like soft rubber. We've never drilled through Europa's crust. It may be tens of kilometres thick. But evidence of water seeps up from the cracks. In 2012, the Hubble Space Telescope spotted what looked like plumes, jets of vapour erupting into space, like geysers in the vacuum. That means the ocean might be accessible, and where there's liquid water, warmth and chemistry, there could be life. Not cities or whales or forests, but microbes. Strange swimmers, silent alien biochemistry. Then there's Enceladus, a tiny moon of Saturn, small enough to fit inside the borders of the United Kingdom, and yet bursting with activity. Its surface too is icy and bright, but at its south pole there are tiger-striped fractures that leak constantly. Plumes of vapour and ice shoot into space from beneath the crust. NASA's Cassini spacecraft flew through these plumes in 2015 and detected organic molecules, complex carbon-based compounds, the kind found in living things. Inside Enceladus may be a warm ocean too. A dark sea with chemical gradients, heat from the core, and the possibility still unconfirmed of life. Not only could we explore this ocean one day, but we may not even need to land. The moon is already spraying its secrets into the void. And then there's Titan, Saturn's largest moon. If the others hint at water, Titan whispers of something stranger. It has an atmosphere, thick and hazy, rich with nitrogen and methane. On its surface are rivers, lakes and seas, not of water but of liquid methane and ethane. It's cold enough there that these hydrocarbons behave like water does on Earth. Rain falls, shorelines form. There are dunes, valleys, and possibly even cryovolcanoes, volcanoes that spew ice instead of fire. Position of 2005, the European Huygens probe landed on Titan and sent back the first images from its surface. Rounded rocks sat in a flat, dim plain. The light was muted, golden-orange, like a sunset that never ends. It was the first landing in the outer solar system, a soft touch on a soft world. Takmail is not warm. It may not be habitable in the way we usually define it. But it is a world with weather, erosion, and layers of chemistry we still don't fully understand. Some scientists believe Titan's surface may mirror what early Earth once looked like. Before life, before oceans, when chemistry was still deciding what came next. Each of these moons, Europa, Enceladus, Titan, holds a kind of quiet possibility, not because we've found life, but because they invite us to keep looking. They remind us that Earth is not the only place where interesting things might be happening, that life, if it exists elsewhere, may not shout. It may whisper from under ice, or behind clouds, or inside jets of vapour we barely notice. Tonight, as you settle deeper into rest, picture those distant moons spinning slowly around giants. Cracked, cold, strange, and possibly alive. Even the solar system has its shadows. Beyond the known, familiar planets, past Neptune's slow orbit, past Pluto's distant curve, there is a region of cold, quiet mystery. A vast ring of icy debris circling the sun in darkness. This is the Kuiper Belt, a region of frozen leftovers, ancient fragments from the dawn of planetary formation. And until recently, it was little more than a theory, a distant fog on the edge of maps. Then came New Horizons. Phased in 2006, the New Horizons spacecraft was a promise wrapped in aluminium and solar panels. Its destination, Pluto, once the ninth planet, later reclassified as a dwarf. For decades, Pluto had been a blurry smudge in our telescopes. No spacecraft had ever been there. We didn't know what we would find. It took New Horizons 9.5 years to reach it. That's how far away Pluto is. so far that the sun itself looks more like a bright star than a blazing disk. But when the spacecraft arrived in 2015, the smudge became a world. Planting is small, just 2/3 the width of our moon, but it's surprisingly complex. It has a heart-shaped ice plain, mountains made of water ice, and an atmosphere that expands and collapses as it orbits. One lobe of its heart, Sputnik Planitia, is a frozen nitrogen basin with strange cell-like patterns that slowly shift, hinting at glacial flows and perhaps even heat from below. It's not a dead rock. It's dynamic, sculpted by forces we still don't fully understand. And orbiting Pluto is Charon, its largest moon, so large that some astronomers call Pluto and Charon a binary system, circling a shared centre of gravity. Charon has its own canyons, its own icy scars, its own story. Didn't stop there. After Pluto, it kept going. In 2019, it passed a tiny world called Arakoth, a contact binary in the Kuiper belt, shaped like a snowman. Two icy lobes, gently fused together, drifting in the dark. Arakoth is old, undisturbed, a pristine time capsule from the early solar system. Its reddish hue, its smooth surface, its unaltered form, all speak to an environment where change is rare and time moves slowly. Far and wide, billions of kilometres filled with icy rocks and dwarf planets we're only beginning to catalogue. It's the source of many short-period comets, and it's the last place where sunlight still holds sway before space turns truly interstellar. Reaches plunge, the temperatures dims, motion slows. And yet, this region is full of potential, new discoveries, new missions, and always new questions. How many dwarf planets are out there? How did these frozen remnants form? Could some of them hold subsurface oceans, like the moons closer in? And beyond the belt, does the solar system end, or just fade? New Horizons is still moving, still listening. Its cameras are off now, but its instruments continue to measure the solar wind, cosmic rays, and the shape of the sun's distant influence. It is leaving the Kuiper belt, approaching the edge of the heliosphere, the invisible bubble carved out by the solar wind. Beyond that lies interstellar space, a new realm. And so the spacecraft drifts, quiet, alone, carrying a small plaque and ashes of Pluto's discoverer, Clyde Tombaugh. A human story, tucked inside a machine, crossing into the dark. Tonight, as you sleep, New Horizons is sailing through the silence, past ice and shadow, past the last whispers of the sun's breath, not toward an end, but into the next unknown. When you look up at the night sky, every star you see is a sun, and most of those suns, perhaps nearly all, have planets of their own. They're called exoplanets, short for extrasolar planets, worlds beyond our solar system, worlds we can't yet visit, but can glimpse through distant light and subtle shadows. They are real, and they are many. Thousands have been found, and each one suggests a possibility, that the universe is not just full of stars, but of systems, families, homes. Minimized, but for a long time we didn't know they were there. Through most of history, we had no evidence of planets outside our own solar system. We assumed they might exist, after all, why should our sun be special? But we couldn't see them, they were too small, too dim, lost in the glare of their parent stars. Trying to spot an exoplanet directly is like trying to see a firefly next to a lighthouse, from hundreds of kilometres away. So, we found another way, or rather, many ways. The first confirmed exoplanet around a sun-like star was discovered in 1995, not that long ago, a gas giant named 51 Pegasi b, orbiting so close to its star that its year lasted just over 4 days. It was a strange place, hot, fast, and completely unlike anything in our own system, but it was real, and it opened a floodgate. Since then, astronomers have developed techniques to find these invisible worlds. One is the transit method, watching for the tiny dip in starlight that happens when a planet crosses in front of its star. The change is barely perceptible, like dimming a stadium floodlight by the flicker of a moth's wing. But sensitive instruments, especially from space-based telescopes like Kepler and TESS, can detect it. Another method looks for a wobble. As a planet orbits its star, its gravity tugs ever so slightly on the star itself, causing it to shift back and forth. By measuring changes in the star's light spectrum, how it leans red, then blue, we can infer the presence of a hidden companion. These techniques don't show us pictures, not usually, but they give us data, mass, size, orbit, temperature, enough to imagine. And imagine we do. We found hot Jupiters, gas giants that orbit scorchingly close to their stars, super-Earths, rocky planets larger than Earth but smaller than Neptune, mini-Neptunes, lava worlds, ocean worlds, and planets with dayside temperatures hot enough to vaporize iron. And even among the strangest of these, we look for one thing: habitability. A place where liquid water might exist, a stable orbit, a temperate zone. Not too close, not too far, just right. Blackmail zone, scientists call it. Playoffs. But exoplanets don't need to resemble Earth to be fascinating. Their diversity is their beauty. Each one is a note in a cosmic symphony. Some may be covered in ice, others may have two suns. Some may be tidally locked, with one side in eternal daylight and the other in endless night. And still, they orbit, quietly, predictably, dancing with their stars in rhythms older than our stories. Tonight, as you lie still, imagine them out there, hidden behind the stars, circling suns with names and numbers, worlds no one has ever seen but that we know are there, like whispers in the dark. The universe isn't just wide, it's full, and we've only just begun to knock on the doors. We search the skies with a quiet longing, not just for the strange or the spectacular, but for something familiar. A world like ours. Blue and green, round and temperate, with clouds drifting above oceans, and maybe, just maybe, something breathing below. We call it the search for Earth 2.0, a place that echoes our own, orbiting a distant sun. And though it sounds like science fiction, it is now science fact. We are looking, and in some cases, we're finding. Demolished, we look for the Goldilocks zone, the region around a star where temperatures might allow liquid water to exist on a planet's surface. Not too hot, not too cold. A quiet lane in the cosmic neighborhood where oceans could remain oceans, not boil away or freeze solid. But that's just the start. A planet might sit in the perfect spot and still be nothing like Earth. It could be a gas world with no surface, a dry rock with no atmosphere, a scorched ball tidally locked so one side forever bakes in light while the other freezes in dark. The right orbit is necessary but not sufficient. Minimized, we look deeper. We examine the planet's size. Is it large enough to hold an atmosphere, but not so large that it turns into a mini Neptune? We study its density. Does it seem rocky or gassy? We look at atmospheric signatures when possible, searching for traces of water vapor, carbon dioxide, maybe even oxygen or methane. Prohibited, these are not signs of life, not directly, but they're the ingredients. The background hum that says, life might be possible here. And some planets stand out. One is Kepler 452b, discovered in 2015. It orbits a star remarkably similar to our Sun, and it lies within the habitable zone. It's larger than Earth, what we call a super-Earth, but it invites speculation. Could it have clouds, mountains, life? Then there's Proxima Centauri b, orbiting the closest star to our own, just over 4 light-years away. That may sound far, but on cosmic scales, it's practically next door. It's a rocky planet in the habitable zone. We don't know what it looks like, or whether it holds water, but we know it's there. We know it's waiting. And there are others. TRAPPIST-1 is a tiny, cool star with 7 Earth-sized planets, 3 of which lie in the habitable zone. They orbit close, so close they'd appear as bright disks in one another's skies. A solar system in miniature, wrapped in endless twilight. Each discovery, what if? A maybe. Habitable doesn't mean inhabited. We haven't found alien cities or distant jungles. We haven't seen lights or heard signals. But the fact that so many potentially habitable worlds exist, more than we ever dreamed, tells us something powerful. Recognize is not alone in its possible escape either. It's about connection, reflection, perspective. A way of asking, what makes Earth special? And perhaps, what would we do differently if we found another chance? So tonight, as the stars wheel silently overhead, remember, they may not be alone. Their planets spin, unseen, unknown, and among them, Somewhere, quietly orbiting in just the right place, there may be a world where a soft wind rustles through alien trees, a world not so different from here. And that thought, like a lullaby, can carry you gently towards sleep. We've never seen most exoplanets directly, and yet somehow we can picture them. A planet with purple skies and orange grass, another with icy rings and twin suns, or one cloaked in permanent twilight with glowing clouds swirling above endless oceans. These are the images we carry, dreams stitched together from science and imagination. But how do we form them when the worlds themselves remain out of reach? The answer lies in light, or rather, in the way that light is altered, bent, dimmed, shifted, when a planet moves in front of its star, or tugs on it, or reflects its glow. From these subtle changes, astronomers begin to reconstruct what cannot be seen. A small dip in brightness tells us the planet's size. A wobble in the star's motion hints at its mass. Combined, we learn its density, whether it's rocky like Earth, gassy like Neptune, or something in between. Broken into spectra can even tell us what's in the planet's atmosphere, if it has one. Water vapour, carbon dioxide, methane, sodium. Each chemical leaves its own fingerprint, a unique absorption pattern that tells us what the planet is made of, and maybe how it behaves. But from those dry measurements, the mind begins to paint. For example, a mini Neptune, about 40 light-years away. It's likely shrouded in thick clouds. Some scientists believe it could have a steamy, water-rich atmosphere. Others wonder if it's entirely wrapped in haze. We can't say for sure, but still, the image forms. A murky, humid world, perpetually dim, with heat pressing in from every side. Precipitation Erpler 186f, an Earth-sized planet in the habitable zone of a red dwarf. Its star is cooler and dimmer than the Sun, so sunlight there would be more orange, more amber. Plants, if they existed, might not be green. Some models suggest they could be black, absorbing as much energy as possible. And just like that, we imagine an alien forest of shadowy leaves, flickering in strange, low light. These visions are not guesses, they're grounded speculations, drawn from physics and chemistry. But they leave room for wonder, for artistic science. Because part of the joy in studying exoplanets is imagining not just what is, but what might be. Science fiction plays a role too. It trains our minds to stretch, to ask, what if a planet was all ocean? What if the clouds rained glass sideways in windstorms? What if gravity was stronger, or the day was shorter, or the sun was red and faint and rose only once a year? And sometimes these ideas loop back into real science. A strange world imagined in a story becomes a target for observation. A wild climate simulated in code leads to a new theory about planetary evolution. The line between what we know and what we can dream blurs softly. That's not a flaw. That's the beauty. Because even when the data is incomplete, we're still part of the picture. Our curiosity, our creativity, our need to imagine, places beyond our feet. We take a curve in a light graph and see a sky. We take a temperature reading and hear waves lapping against a distant shore. And maybe one day, long from now, a real photograph will arrive. A snapshot from a probe sent to one of these far-off places. Maybe it'll show us something no artist ever painted, no scientist ever guessed. Or maybe it'll look a little like the image you're holding in your mind right now. Until then, we imagine. Not blindly, but boldly, gently, with science in one hand and wonder in the other. On Earth, the sky follows a rhythm we know by heart. One sun rises, arcs across the sky and sets. Day becomes night, light fades to dark. It's simple, predictable, comforting. But not every planet is so lucky. The quiet reaches between stars are worlds that orbit not one sun but two. Binary star systems. Two luminous bodies circling each other in a gravitational ballet, and in their midst a planet caught in the middle of their dance. Imagine standing on the surface of such a world. The sky would hold two suns, sometimes close together, sometimes on opposite ends of the horizon. At times one might rise while the other sets. or both might hang in the sky at once, casting twin shadows behind every rock, every tree, if there are trees. Light would be layered, overlapping, complicated. Days would stretch and twist in ways our bodies aren't built to follow. These are not science fiction dreams. We've found such worlds. In 2011, NASA's Kepler telescope discovered Kepler-16b, the first confirmed circumbinary planet, a world that orbits 2 stars. And since then, more have been added to the list. Kepler-34b, Kepler-47c, and others with names like star maps and quiet whispers. Kepler-16b itself is about the size of Saturn, probably a gas giant, unlikely to host life. But it orbits its stars in perfect balance. From its skies, you might see a double sunrise, a solar eclipse as one star passes in front of the other, or perhaps long seasons shaped by the ever-shifting tug of dual gravity. Not all binary systems are calm, some are too close, stars circling so rapidly that any nearby planet would be flung apart. Others are too far, making the gravitational balance too unstable for long-term orbits. But in the gentle middle, where balance holds, planets can form and survive, and those that do may experience a kind of sky we've only imagined in stories. The physics of such systems is fascinating. A planet around 2 stars feels their combined gravity. It doesn't swing neatly around one or the other. Its orbit can wobble, stretch, or slowly precess over time. Temperature patterns may be wildly complex, with light levels changing not just daily, but across intricate cycles of months or years. And yet, there is order. There are stable paths. The cosmos allows for these peculiar configurations and sometimes even favors them. In fact, binary and multi-star systems are more common in the galaxy than single stars like our Sun. Most stars you see in the night sky probably have a companion, another sun, dancing just out of sight. What would it feel like to grow up under 2 suns? Maritime of time be different? Would plants learn to lean toward one light, then the other? Would seasons be poetry, not calendar? Would your mythology tell of twin creators, twin guardians, twin endings? Confiscated, no. But the fact that such questions are no longer hypothetical, that we found these worlds, measured the skies, mapped their orbits, is itself astonishing. Tonight, while your eyes close beneath the soft glow of a single moon, know that far beyond, in places untouched and unnamed, there are worlds basking in the light of twin suns. Their skies are golden and strange. Their shadows are doubled, and their very existence reminds us that nature allows for more than we ever imagined. Sometimes it allows for wonder made real. There's a telescope 1,000,000 miles from Earth, floating at the edge of a shadow. It doesn't orbit the Earth like Hubble. Instead, it orbits a point, a delicate balance spot called L2, where the gravity of Earth and the Sun align just so. There, in cold silence, the James Webb Space Telescope unfolds its golden mirror and listens to light that has travelled across time. Confiscated doesn't see invisible light like our eyes. It sees an infrared, a deeper, quieter part of the spectrum. This allows it to pierce through dust, to sense warmth, to gaze into the farthest past. With Webb, we can see galaxies forming just a few 100 million years after the Big Bang. Light that began its journey before Earth even existed is only now arriving at its mirror. But Webb doesn't only look at the distant past, it also looks sideways, at stars not so far away, and the planets that circle them. With precision, it studies the spectra of exoplanets as they pass in front of their suns. When starlight filters through a planet's atmosphere, certain wavelengths are absorbed, fingerprints of the molecules that drift there. Water vapour, methane, carbon dioxide, perhaps one day oxygen. Already Webb has studied planets like WASP-39b, a hot gas giant with a bloated atmosphere, and found detailed chemical signatures. Not just vague hints, but clear, confident detections. Clouds, haze, layered elements, each one telling a story of the planet's climate, its winds, its skies. And this is just the beginning. What makes Webb extraordinary isn't just its sensitivity, it's its calm, its stability. Shielded by a 5-layer sunshade, cooled to near absolute zero, it detects heat that is unimaginably faint. It can see the warmth of a distant planet's atmosphere. It can track the slow glow of forming stars in dusty nurseries. It can stare deep into places where light itself has barely begun to emerge. In a way, Webb is not just a telescope, it's a kind of memory, a mirror that remembers things older than us. Galaxies stretching into filaments, black holes shaping early clusters, the first moments when atoms gathered, cooled and kindled stars. But it's also a dream catcher, because every time Webb studies a distant planet's atmosphere, we edge closer to an answer we've been quietly asking for centuries. Are we alone? The answer won't arrive in a flash. It may come gently, as data, as a wobble in a spectrum, as a line on a graph. But when we find an atmosphere rich in oxygen, methane or other biosignatures, not just once but again and again and again, we'll know. Not for certain, but enough to wonder, with more than hope. And even if we don't find life, not yet, Webb still changes how we see everything. That stars aren't just pinpricks, but cradles. That planets aren't just points, but places. That the universe is not a backdrop, but a growing, glowing thing, alive with heat and dust and motion. Tonight, as you will continue to peer, rest beneath a sky that hides so much. Remember that above it, far beyond the air and clouds, there's a golden mirror reflecting the past, watching exoplanets breathe, reading light like a language, whispering across space, softly, that we are learning, and that the sky still holds stories we have not yet told. There's something paradoxical about exoplanets. The more of them we find, the farther we seem from each one. Thousands of distant worlds orbiting suns we'll never touch. Some are close, astronomically speaking, just a few dozen light years away. But even that is unimaginably far. With our fastest spacecraft, it would take tens of thousands of years to reach even the nearest. And yet, knowing they're there makes us feel less alone, kind of comfort, like looking across a wide, empty ocean and spotting a flicker of firelight on a distant shore. We may never reach it, but someone, something, might be there. Or maybe not. But the possibility changes everything. It reminds us that Earth is not the centre of the story, just one chapter among many. A tendency, when looking out into space, to feel small. And yes, the numbers are staggering. Billions of stars, billions of planets, trillions of kilometres between us and them. But small does not mean unimportant, and distant does not mean disconnected. The discovery of exoplanets reframes our sense of place. It doesn't diminish Earth, it illuminates it. Because in all our searching, all our sky scanning and data sifting, we found nothing quite like this pale blue world. Not yet. Earth remains for now a singular jewel. Blue oceans, white clouds, green life, and the gentle breath of atmosphere. The fact that we can compare it to thousands of other worlds and still find it extraordinary is a quiet celebration of everything we are. At the same time, it expands our empathy. If other worlds exist, some of them may host life. Not necessarily civilizations, but simple life. Microbial, photosynthetic, swimming in alien seas. And if that's true, even just in one other place, then life is not an accident. It's a tendency, a feature, not a fluke. That changes how we think about life here too, about forests and plankton, insects and coral, about ourselves. We begin to see life not just as a local phenomenon, but as a cosmic one, a thread the universe keeps trying to spin. And even if we never find life elsewhere, the act of looking brings us together, across telescopes and languages, across decades of effort and imagination. We are united by the same question. Are we alone? That question crosses borders, it survives generations, and it humbles us in the best way. Because searching for exoplanets isn't just a scientific project, it's a human one. It blends our curiosity with our yearning. It fuses hard data with gentle hope. Tonight, as you close your eyes, remember that above you, In the quiet dark, the search continues. Telescopes turn, signals whisper, distant stars blink in rhythm, and around them, planets spin, each with its own sky, its own rhythm, its own silence, flaming, somewhere out there, another. A galaxy is not a single thing, it is a gathering, a slow accumulation of stars, dust, gas, gravity, and time. You could think of it as a city of stars, bright and busy at the centre, quieter at the edges, connected by invisible currents. Or, like a snowflake, unique in structure, but shaped by simple rules playing out across a very cold sky. Poisoned we live in, our Milky Way, is just one among many. But before we drift there, let's pause and breathe in the idea of a galaxy itself. What is it, really? Axie is held together by gravity. That gentle pull, so soft we barely notice it here on Earth, becomes the architect of everything large and luminous in the universe. Over billions of years, gas clouds collapsed, stars ignited, and clusters of them swirled into patterns, spirals, ellipses, scattered splashes of light. Galaxies. There are hundreds of billions of them, maybe more, each one with its own history, its own shape, its own story written in stars. Blankets are spiral, like the Milky Way, with curved arms sweeping outward from a dense central bulge. These arms are not solid structures, but waves of higher density, regions where gas slows down just enough for stars to be born, like traffic building up on a cosmic highway. In images, they look like pinwheels, delicate and grand. Others are elliptical, rounder, older, quieter. They don't spin in the same way. They lack the crisp structure of spiral arms. Their stars orbit more randomly, and many of their new stars have long since finished forming. These galaxies glow with the soft light of aged suns, like the fading embers of a once roaring fire. Plagued. And then there are the irregular galaxies, asymmetrical, chaotic, shaped by collisions or gravitational tugs. They don't follow the typical rules. They look like spills or fireworks or clouds of starlight gently unravelling. Position each type tells us something about what's happened to it. Galaxies are shaped by both their origins and their interactions, by quiet growth and violent merger, by tides and time. Blackjack and they're big, so very big. A typical spiral galaxy might span 100,000 light years across. That's how long light, travelling at the fastest speed there is, takes to cross from one end to the other. Some giant galaxies are even larger. Others are smaller, like dwarf galaxies, which are still vast, still home to billions of stars, and still orbit larger galaxies, like gentle satellites. No matter the shape or size, galaxies tend to share a few quiet traits. Contain stars, of course, but also nebulae, clouds of gas and dust, where stars are born, and black holes, especially at the centre. Most large galaxies harbour supermassive black holes in their cores. We can't see them directly, but we know they're there from the way stars swirl around invisible points, like leaves circling a drain. Any galaxies is a halo, a faint spherical region filled with something we can't yet see. Dark matter. This invisible mass reveals itself only through its gravitational effects, like a presence just beyond our reach, holding everything in place. So a galaxy is not just stars, it's structure, it's history, it's motion, frozen in light. Tonight, if the skies are clear, you might even see one with your own eyes. The faint smear of Andromeda, a neighbour galaxy, just visible to the naked eye in the dark. From here it looks like a whisper, but up close it's a sea of 1 trillion stars, each as real as our own sun. Truth about galaxies. They are not distant things. You are in one, right now, floating in its gentle spin. Breathing stardust, made from elements forged in stars. You are not apart from it. You are part of it. You're already in a galaxy, right now, right here. You don't have to go anywhere, you are suspended within it, held gently like a speck inside a snow globe slowly turning. The stars you see when you look up, they're part of it too. Neighbours on the same street. lights from the same neighbourhood blinking quietly across vast distances. This is the Milky Way, our home galaxy. And though we live inside it, we've never seen it from the outside, not truly. We imagine it based on where the stars are, how they move, how they cluster. It's a bit like trying to understand the shape of a forest while standing under the branches. You can look in every direction, measure angles and distances, but the full picture always remains just out of view. Principals, still, we've pieced it together. The Milky Way is a barred spiral galaxy, a glowing disk with arms that twist outward, and a central bar-shaped bulge of stars in the middle. It spans about 100,000 light-years across, and we're tucked into one of its quieter suburbs, about 27,000 light-years from the centre, in a gentle spiral arm called Orion's Spur. If you were to rise above the galaxy and look down, you'd see 4 major arms curving outward, filled with stars, gas clouds, and star-forming regions. You'd see the bright, dense core glowing in the middle, where the stars pack tightly together, orbiting a supermassive black hole we call Sagittarius A star. And you'd see the disk thinning toward the edges, wrapped in a halo of older stars and unseen dark matter. What we see is different. On a clear, dark night, far from city lights, you might notice a band of hazy light stretched across the sky. It looks like a cloud, or maybe a river. The ancients called it milk spilled across the heavens, a celestial path, a road for gods. Controlled, you're actually seeing is the plane of the galaxy, edge on. You're looking through its dense midsection, hundreds of millions of stars, layered and packed, blurred by distance and dust. That glow isn't a single object. It's thousands, millions, each point a sun, too far and faint to be resolved on its own. Flames isn't still. The whole galaxy is rotating, slowly, majestically. Our solar system takes about 230 million years to make one full orbit around the galactic centre. That means the last time we were in this position, dinosaurs walked the Earth. A galactic year. Blackjack, even now we're moving, carried by gravity, looping along a gentle curve. And as we move, the galaxy changes too. Stars are born and die, gas clouds drift, clusters collide. The shape of the arms shifts slightly, like ripples in water. And yet, it feels so calm. Stabilize. It's the scale. So vast that change seems frozen. Or maybe it's because we've always known it, always lived in it, always looked up at its light and found meaning there. Myths, constellations, navigation. Even now we build telescopes to peer deeper into its heart, to learn more about where we come from. Because that's what the Milky Way is. Not just a location, but a lineage. A place that shaped us. Every atom in your body was once part of a star that lived and died here. You are made from this galaxy. You are its dust, its carbon, its oxygen, its echo. So tonight, if the sky is clear, look for that faint, milky band overhead. Let your eyes adjust. Let the glow sharpen. And remember, you are not beneath the galaxy. You are inside it. If you could step outside the Milky Way and float in the stillness of space, you'd begin to see it not as an isolated swirl, but as part of a quiet gathering, a local group of galaxies drifting together through the dark. Our galaxy is not alone. It never has been. The most prominent of our neighbours is Andromeda, a spiral galaxy like our own, just a little larger and around 2.5 million light-years away. That number sounds vast, and it is, but on the scale of the universe, Andromeda is our closest large companion. If the Milky Way is a city, Andromeda is the next town over, just past the hills, glowing softly with its own street lamps of starlight. On a clear night, you can see it with the naked eye, a faint, misty oval in the northern sky. From here, it looks small and fragile, like a thumbprint on a telescope lens. But in truth, it holds over 1 trillion stars, entire solar systems, whole histories, and we're heading toward it. Slowly, at about 110 kilometers per second, the Milky Way and Andromeda are on a collision course. But don't worry, it won't happen for about 4 billion years. And even when it does, it won't be a crash in the way we think of one. Galaxies are mostly empty space. Their stars are so far apart that when galaxies collide, almost no stars actually hit each other. Instead, the two galaxies will pass through one another, drawn together again by gravity, their shapes stretched and tangled by tidal forces. They'll swirl, ripple, and eventually settle into a new form, perhaps a large elliptical galaxy, born not from destruction, but from union. It will be a long, graceful dance, one lasting billions of years, and by the time it's done, the night sky from Earth, or whatever world remains, will be completely transformed. But Andromeda isn't our only neighbour. There are the Magellanic Clouds, two irregular dwarf galaxies visible in the southern hemisphere. The large Magellanic Cloud, LMC, and the small Magellanic Cloud, SMC, are like satellites orbiting our galaxy. They're close enough that their stars can be resolved with modest telescopes, and they've long been part of indigenous sky lore, named, charted, watched. The LMC is about 160,000 light-years away and contains regions of intense star formation, including the Tarantula Nebula, one of the most active nurseries in the nearby universe. These galaxies aren't just ornaments, they interact with the Milky Way, they stir its halo, they trigger waves of star formation, they leave ripples in the disk, like pebbles dropped into a cosmic pond. Altogether, the local group contains more than 80 known galaxies. Most are small, dim dwarfs, so faint we didn't even know they existed until recently, but they orbit, they merge, they evolve. The local group itself is part of a larger structure, the Laniakea supercluster, stretching out over 500 million light-years.
Spin in isolation. It moves in relation to its neighbours, pulled slightly here, pushed gently there. Over time, these motions write the slow story of the cosmos. Tonight, while you drift into sleep, know that galaxies are drifting too, that even in the darkness between stars there is motion, that the Milky Way and Andromeda are approaching, slowly weaving their paths toward one another. Not in violence, but in gravity's quiet choreography. Because in the end, the universe isn't just expanding, it's dancing. If you could step outside the Milky Way and float in the stillness of space, you'd begin to see it not as an isolated swirl, but as part of a quiet gathering, a local group of galaxies drifting together through the dark. Our galaxy is not alone. It never has been. The most prominent of our neighbours is Andromeda, a spiral galaxy like our own, just a little larger and around 2.5 million light-years away. That number sounds vast, and it is, but on the scale of the universe, Andromeda is our closest large companion. If the Milky Way is a city, Andromeda is the next town over, just past the hills, glowing softly with its own street lamps of starlight. On a clear night, you can see it with the naked eye, a faint, misty oval in the northern sky. From here, it looks small and fragile, like a thumbprint on a telescope lens. But in truth, it holds over 1 trillion stars, entire solar systems, whole histories, and we're heading toward it. Slowly, at about 110 kilometers per second, the Milky Way and Andromeda are on a collision course. But don't worry, it won't happen for about 4 billion years. And even when it does, it won't be a crash in the way we think of one. Galaxies are mostly empty space. Their stars are so far apart that when galaxies collide, almost no stars actually hit each other. Instead, the two galaxies will pass through one another, drawn together again by gravity, their shapes stretched and tangled by tidal forces. They'll swirl, ripple, and eventually settle into a new form, perhaps a large elliptical galaxy, born not from destruction, but from union. It will be a long, graceful dance, one lasting billions of years, and by the time it's done, the night sky from Earth, or whatever world remains, will be completely transformed. But Andromeda isn't our only neighbour. There are the Magellanic Clouds, two irregular dwarf galaxies visible in the southern hemisphere. The large Magellanic Cloud, LMC, and the small Magellanic Cloud, SMC, are like satellites orbiting our galaxy. They're close enough that their stars can be resolved with modest telescopes, and they've long been part of indigenous sky lore, named, charted, watched. The LMC is about 160,000 light-years away and contains regions of intense star formation, including the Tarantula Nebula, one of the most active nurseries in the nearby universe. These galaxies aren't just ornaments, they interact with the Milky Way, they stir its halo, they trigger waves of star formation, they leave ripples in the disk, like pebbles dropped into a cosmic pond. Altogether, the local group contains more than 80 known galaxies. Most are small, dim dwarfs, so faint we didn't even know they existed until recently, but they orbit, they merge, they evolve. The local group itself is part of a larger structure, the Laniakea supercluster, stretching out over 500 million light-years.
Spin in isolation. It moves in relation to its neighbours, pulled slightly here, pushed gently there. Over time, these motions write the slow story of the cosmos. Tonight, while you drift into sleep, know that galaxies are drifting too, that even in the darkness between stars there is motion, that the Milky Way and Andromeda are approaching, slowly weaving their paths toward one another. Not in violence, but in gravity's quiet choreography. Because in the end, the universe isn't just expanding, it's dancing.
We've drifted far now, beyond stars, beyond galaxies, into something even larger. If galaxies are cities of stars, then those cities do not float alone in a black void. They are connected, arranged in a vast structure that defies ordinary imagination. Roads between them made not of stone but of gravity. Clusters, filaments, walls, and between them emptiness so wide and still it feels almost sacred. This is the cosmic web. A company we map the distribution of galaxies across billions of light-years. A pattern emerges, not scattered chaos, but a kind of woven structure. Galaxies and galaxy clusters trace out luminous threads, forming long filaments and massive walls. Between them lie vast voids, regions with almost no galaxies at all. These voids are not truly empty, but they are remarkably quiet, sparse like dark lakes between mountain ranges of light. Our home, the Milky Way, is part of a local cluster of galaxies called the Local Group, and that group is tucked into an even larger structure known as the Laniakea supercluster. The name means immense heaven in Hawaiian, and it's fitting. Laniakea spans over 500 million light-years and contains around 100,000 galaxies. And yet, even this enormous region is not the largest structure we've seen. Across the sky, we found features like the Sloan Great Wall and the Hercules Corona Borealis Great Wall, structures made up of countless galaxies bound into long, sprawling ribbons. These are among the largest known features in the observable universe, stretching across billions of light-years. But size alone doesn't make them impressive. It's their pattern, the way these galaxies arrange themselves, not randomly, but with a kind of gravitational memory. It's as though the early universe laid down a framework, and all the galaxies since have flowed into its grooves. Migrated are not chaotic. They are shaped by gravity, by the expansion of space and by the pull of dark matter, which acts like scaffolding for the entire structure. Over billions of years, matter has gathered in these filaments and drained out of the voids. And as it did, galaxies formed along the densest intersections, like frost gathering on the edges of a window pane. The largest presence condones in the profit of the existence of grooves. If I fall into the traces of the commenty, and almost a mention to a universe, they form the matter-first treatments increasing a sepsive implemented, they conjuring the large traces of grooves and together in this crane. One largest transient is almost formed to our reserve 2 times Trican, which is the way we discovered these shapes is poetic. Astronomers map redshifts, how much the light from distant galaxies has stretched as the universe expands. From this, they create 3-dimensional maps, plotting millions of galaxies in space. When seen from afar, these maps look like lace, like coral, like lightning frozen in glass. Their phonology that we seen my peoples at the plusful have created, these are billion seas, bite choiting known, are active presented that everything we know, our galaxy, our solar system, our entire sky, sits on one thread of that vast web. Peacefully and between those threads lie the voids, places where galaxies are rare, where matter seems to have thinned and drifted away. These are not places we can easily... is not absence, but balance.
So tonight, as you close your eyes, try to picture it. A universe woven together like a tapestry of light, galaxies drawn into luminous filaments, voids wide enough to hold 1,000 galaxies in silence, all expanding, all shifting, all part of one enormous breath, stretched across time. And somewhere in one of those filaments, orbiting a quiet star on a quiet arm of a quiet galaxy, you. There's a photograph, a quiet one at first glance. No planets, no famous stars, just tiny specks scattered across a black background. It might seem unremarkable, but this image changed how we see everything. It's called the Hubble Deep Field. In 1995, the Hubble Space Telescope turned toward what appeared to be a completely empty patch of sky. A patch so small it would take a grain of sand held at arm's length to cover it. No bright stars, no nearby galaxies, just darkness. Gambling. And then it stared. Floating for 10 days, Hubble collected light from that tiny square over 1 million seconds of exposure. Bit by bit, the photons arrived, whispers from deep time, some travelling for billions of years. And when the image was complete, something extraordinary appeared. Not emptiness, not silence, but galaxies. Thousands of them. Spirals, ellipticals, irregular shapes, red, yellow, blue, some bright and nearby, some faint, red-shifted, ancient. Every point of light in the image, except a handful of stars, was an entire galaxy, each one holding billions of stars, each one potentially harbouring worlds and clouds and questions. And all of it compressed into that one narrow field. It was like taking a deep breath and realising you'd been underwater all along. What made the Hubble Deep Field so profound wasn't just what it showed, it was what it implied. If that much structure, that much light, that much cosmic history could be found in one tiny sliver of sky, then how much more must be out there? The answer? Hundreds of billions of galaxies, maybe more, all scattered across the observable universe, each with its own stars, its own black holes, its own dust and light and shadow. The scale became not just unimaginable, but beautifully overwhelming. Later versions of the deep field came too. The Hubble Ultra Deep Field in 2004, the Extreme Deep Field in 2012, each pushing deeper, revealing fainter and earlier galaxies. And now, with the James Webb Space Telescope, we're seeing even farther back, closer to the first stars, the first moments of structure. But that original deep field still feels special. There was something bold about it, something quiet and daring. To look into what seems like nothing and trust that something is there. To believe in light so faint it can barely whisper, and then to listen. In many ways, a kind of cosmic patience, a willingness to wait for the sky to speak. Hubble Deep Field told us is this: the universe is full, not just of matter or stars or motion, but of history. Each faint smudge of light in that image is old. Some are so far away that we're seeing them as they were just a few 100 million years after the Big Bang. Light travels at a fixed speed, so to look far is to look back. Time and distance become the same thing. When you gaze at such an image, you're not just seeing where galaxies are, you're seeing where they were. Your past in the present. A photograph of when the universe was young. And you were part of that story. Your atoms were forged in stars like the ones in that image. Your planet formed in a galaxy like one of those distant swirls. And now, billions of years later, your eyes have opened and you are looking back. Swallowing. If you feel small, remember, you are the only part of the universe you know of that can see the rest, that can feel wonder, that can point a telescope into darkness and find light. Forging, you are not apart from the universe. You are how the universe looks at itself. If the Hubble Space Telescope gave us our first clear glimpse into deep time, then the James Webb Space Telescope is something quieter, more like a second heartbeat, a deeper breath, a softer eye, tuned not to brightness, but to warmth. Webb doesn't see the universe the way we do. It sees in infrared, a kind of light that stretches beyond the red our eyes can detect. That difference is subtle but profound, because the oldest galaxies, the ones born when the universe was young, have their light stretched, expanded and softened by the universe's own growth. What began as ultraviolet and visible light has become warm, dim and red with age. To see those ancient galaxies, you need a telescope that sees warmth, one that listens for faint heat across the cold vacuum of space. That's exactly what Webb does. In Webb opened its golden eyes for the first time, astronomers saw something surprising. Galaxies appeared where we hadn't expected them, bright, well-formed and very old. Too old, perhaps, for how early in cosmic time they were showing up. These weren't dim clouds of protostars. They had structure. They glowed with maturity. Some of these galaxies seem to have formed within a few 100 million years after the Big Bang. And that's puzzling, because according to many models, there shouldn't have been enough time for such complexity yet. So either the models need adjusting, or the universe was busier, faster, more efficient than we thought. Playoffs, but puzzling is not a problem. Puzzling is an invitation. Each strange galaxy Webb reveals is a new question mark hanging delicately in the dark. Why is it so bright? How did it grow so fast? Is it truly a galaxy, or something stranger? A supermassive black hole glowing in disguise? A merger caught in the act? Let us see the details of galactic structure at these early stages. In some cases, the galaxies are clumpy, irregular, like cosmic embryos just starting to stretch. In others, they seem smooth and settled. Each shape tells a story of star formation, of collisions, of dust and time. Webb can see infrared. It can pierce through the gas and dust that often obscure galaxies, both near and far. It reveals hidden regions, star nurseries cloaked in veils, places where stars are being born right now, glowing gently behind curtains of interstellar material. Peacefully, Webb the way, Webb doesn't just look far, it looks through clouds, through layers, through time. And yet, for all its power, there's something tender about what it does. It doesn't shout, it waits, it stares, it collects light too old to remember where it started. It listens for the universe's quiet beginnings, the flickers of galaxies rising in a sea of dark. It does that seeing is not always about brightness. Sometimes it's about patience, sensitivity, the ability to hear a whisper that others missed. Tonight, as you fall into your own quiet orbit of sleep, know that far above Earth's warmth, floating in a cold, careful shadow, there is a telescope catching ancient light, reaching across billions of years, reading the early chapters of everything. Not because we need to escape the present, but because sometimes, to understand where we are, we must first remember how it all began. Galaxies don't speak. They don't write. They don't dream. And yet somehow, they feel like stories. Maybe it's because they're made of motion, of orbits and spirals, of collapses and collisions, like plot lines, pulled slowly through time. Maybe it's because they hold memory of ancient stars long gone, of light that still travels even after its source has faded. Or maybe it's simply because we're in one, and everything around us feels like part of a narrative we've only just begun to read. Windshield. When you look at a galaxy, what you're really seeing is change, stretched out. The glow of young stars forming in nebulae. The drift of older stars into the outskirts. The scars of old mergers. The shadows of dark matter shaping paths unseen. Each swirl, each bulge, each quiet glow is a chapter written in gravity and dust. The stars inside galaxies don't just sit still, they orbit, they drift, they interact. Stars are born, burn and die. Supernovae burst like exclamation points, scattering heavier elements into the galactic soup. Over billions of years, new stars take shape from those ashes. Planets form, some barren, some possibly blue. In that way, galaxies are storytellers, but also libraries. Each one contains countless individual journeys, every planet, every molecule, every spark of life if it exists, playing its own thread through the spiral. Aren't confined to a single galaxy. Galaxies interact too. They pull on each other, collide, merge. Their shapes distort. Their cores may light up with fierce black holes. And then, slowly, they settle. New forms, new rhythms. One story ending, another beginning. In the same way you might look at the rings of a tree or the layers in a canyon wall, astronomers read galaxies like records. They measure the metallicity of stars to trace when heavy elements first appeared. They model star distributions to understand old collisions. Even the motion of stars tells us something, whether they were born in this galaxy or captured from another. Galaxies, in this sense, are both archives and autobiographies. But there's something softer at play too, something less measurable. When you look at a galaxy, especially from afar, you might feel something you can't name. Not awe exactly, not fear, something like longing, as though you're glimpsing a place you once knew or might someday return to. A kind of gravitational nostalgia. Stabilized, does that feeling arise? Prosecute perhaps because galaxies remind us of time not as numbers but as experience. Slow time, cosmic time, time that folds and loops and stretches. They remind us that the universe does not rush, that meaning doesn't always arrive quick. Luminous. So when you look at a galaxy, try not to see it as a thing. See it as a story, still unfolding. One you were born into, one you're helping to tell. And tonight, as you drift into sleep, know that the galaxy is still turning, slowly, gently, carrying you with it, across millions of years, past nebulae and clusters and dark halos, in a spiral arm that remembers everything. It has no ending. Only. Imagine you're floating in the middle of space, calm, still, and perfectly silent. No planets, no moons, just stars in every direction, some bright, some faint, some so far away that they might only exist as a whisper of light in your eyes. Now imagine drawing a sphere around yourself, not made of glass or metal, but of light and time. This is your observable universe. It's not the whole cosmos, it's simply the part you can see, because even light has limits. Locksmith travels fast, 299,792 kilometers per second. But the universe is vast, and it's been around for 13.8 billion years. That means the farthest light could possibly travel to reach us today is, well, you'd think it's 13.8 billion light years. But it's not. It's more than 45 billion light years in every direction. Why? Because while the light was travelling to us, the space it was moving through was expanding, stretching like dough rising in a slow oven. So the galaxies that emitted that ancient light are now far farther away than they were when they sent it. When we say the observable universe is about 93 billion light years wide, that's what we mean. Not the distance the light travelled, but the current distance to the places that light came from. It's like hearing a song from a distant hilltop, only to realise the singer has walked even farther away since they began. But here's the tender part. This sphere of visibility is centred on you, not because you're special, but because that's how light works. Every observer, no matter where they are in the universe, sees their own version of this bubble, each one defined not by walls or borders, but by time. We see galaxies, not as they are now, but as they were, millions or billions of years ago. Some of the stars you see when you look up may no longer exist. Their light is still crossing the void, like postcards sent from vanished homes. And what lies beyond the edge of the observable universe? We don't know. Not because it isn't there, but because its light hasn't reached us yet. It's as though the cosmos is a vast ocean, and we're watching waves roll in from a distant storm, knowing the horizon is not the limit of the sea, only of what we can perceive. This doesn't make the universe smaller,
It makes it deeper. It means that when we gaze into space, we're really gazing into history. Every image from a telescope is also a fossil, a slice of time arriving now. The further out we look, the further back we see. And that raises an odd, beautiful truth. The edge of what we can see isn't made of matter, it's made of time itself. So when we say observable universe, what we mean is the part of the past we can still see today. It's not a boundary we can reach. It's a fading record of ancient light. And beyond it, galaxies, space, more. Tonight, while your own vision softens, remember this. You live inside a bubble of light. A glowing sphere, not built by walls or wires, but by the soft limits of time. And everything within it, the galaxies, the whispers, the light that took billions of years to arrive, is your view of the universe. Not all of it, but enough to wonder. Light is quiet. It doesn't push or pull. It doesn't rumble or shake. It simply travels, softly, steadily, across the endless stretch of space, carrying stories with it. When you look up at the stars, you're not seeing them as they are. You're seeing them as they were. Some just a few years ago, some thousands, some millions. Every beam of light that reaches your eyes tonight began its journey long before you were born. In this way, light is more than brightness. It's a messenger, a thread between now and then, a way for the universe to speak, one flicker at a time. But that message changes as it travels, because the universe isn't still. It's stretching, expanding. As light moves through that expanding space, its wavelength also stretches, like a rubber band pulled slowly outward. The result? Light shifts toward the red end of the spectrum. We call this red shift. It's not because the light itself is red, but because its colour has shifted due to the space it passed through. A galaxy that emitted bluish-white light billions of years ago might now appear as a soft red smudge in a telescope's eye. Not because the galaxy changed, but because space itself changed while the light was on its way. The farther the light had to travel, the more the universe expanded during its journey, and the more the light was stretched. So redshift becomes a kind of distance marker. Not just for where something is, but for when it was. This is one of the quiet miracles of astronomy. The farther we look, the older the universe becomes. A telescope is not just a tool for distance, it's a time machine. Each red-shifted galaxy we observe is not just far away, but ancient. We see it not as it exists today, but as it once was, long ago, in the infancy of stars. The most distant galaxies Webb and Hubble have observed are so red-shifted, they were born just a few 100 million years after the Big Bang. When you look at them, you're looking at baby pictures of the universe, sepia-toned, slightly blurry, but full of meaning. And yet, this starlight, this time-travelling glow, is fragile. It's easily blocked by dust, drowned by atmosphere, scattered by light pollution. That's why we send telescopes into space, to rise above the noise, to listen carefully. Pregnancies, the whispers. Every photon that reaches us has survived a journey of impossible length. It has passed through clouds of gas, past galaxies and dark matter halos, through curved space and cosmic microwave background radiation. It has travelled not in a straight line, but through a universe that's been stretching and folding beneath it. And still, it arrives, silent, ancient. Into one low on the horizon, flickering faintly in the dusk. Pause for a moment. That light has travelled years to reach you. It began before your day did, before your life did. It has crossed the quiet distance just to rest briefly in your eyes. And then, like all light, it goes on. Imagine the universe as a vast, dark room. For a long time, it was filled with light. But the air was so thick the light couldn't travel. It bounced, scattered, tangled in the dense crowd of particles, like trying to see through thick fog with a flashlight. The beam never gets very far. Then suddenly, the fog thinned. Roughly 380,000 years after the Big Bang, the universe cooled just enough for protons and electrons to combine into neutral atoms. The fog lifted, and in that instant, light was free to travel in straight lines, free to stretch its arms and begin a journey across space. That ancient glow still surrounds us. We call it the cosmic microwave background, or CMB, a faint, persistent radiation left over from the universe's earliest visible moment. It's not light we can see with our eyes. It's microwave radiation, low energy, long wavelength light that fills the universe like the ghost of a sunrise that never ended. Discovered by accident in 1965 by Arno Penzias and Robert Wilson, the CMB is often described as the afterglow of the Big Bang. They weren't looking for it. They were just trying to eliminate background noise from a radio antenna. But no matter what direction they pointed, the noise remained. That noise, it turns out, was the quiet warmth of the universe itself. When scientists mapped it in more detail, they found it wasn't perfectly uniform. There were tiny temperature fluctuations, ripples in the early universe. These ripples mattered. They were the seeds of structure. Over time, those slightly denser regions became galaxies, stars, planets. Us. Forging of the CMB looks like a soft blur of blues, oranges, and yellows, a baby picture of the universe. Not taken with a camera, but with instruments like the COBE, WMAP, and Planck satellites. These maps don't just show where the universe came from. They help us understand how it's shaped, how it's expanding, and what it's made of. From the CMB, we learn that the universe is remarkably flat. Not in shape, but in geometry. We learn its age, its composition, and how fast it's expanding. We learn about dark matter, dark energy, and the strange forces still influencing the cosmos today. And we learn, perhaps most beautifully, that the entire universe once glowed. Not metaphorically, literally, before stars, before planets or atoms as we know them, the universe was light, hot, dense, and bright. The CMB is the faded memory of that brilliance, a soft hum echoing through space, too quiet for our ears, but always there. And it touches everything. No matter where you are in the universe, on Earth, on a spacecraft, or drifting between galaxies, you would see the CMB. Same in every direction, same temperature, just a few degrees above absolute zero. A kind of rest under your own blanket, imagine another. One far older, aglow, not from lamps or candles, but from the very first breath of light, still glowing, still humming, still telling the story. It's natural to imagine the universe expanding like an explosion, stars and galaxies flung outward from a central point rushing through space like fireworks. But that's not quite right. Crimson even isn't expanding into space. Space itself is expanding, slowly, steadily, and everywhere at once. It's a gentle drift, not a burst, a stretching of the fabric, not the motion of things within it. Galaxies aren't flying through space like ships across water. Instead, the water itself is rising, carrying the galaxies with it, like raisins in a loaf of bread as it rises in the oven. Or like dots drawn on a balloon. The assumption you take a balloon and mark it with tiny dots. As you blow air into it, the dots move away from each other, not because the dots themselves are moving, but because the surface between them is stretching. That's how the universe grows. Not from a centre, not toward an edge, just everywhere, evenly, all at once. This idea feels strange at first because we're used to motion having direction. We want to point to where it all began, we want to find the origin point. The universe, every point is expanding away from every other point. No matter where you are, it appears as though everything is receding from you. If you were in a distant galaxy, you'd see the same thing, the universe growing in all directions, just as we do from here. It's not an illusion, it's just that space itself is increasing, and the farther away something is, the faster it seems to recede. This is Hubble's law, one of the foundational discoveries of modern cosmology. It tells us that space between galaxies isn't static, it stretches, slowly, quietly, without sound. No roar, no vibration, just the math of distance, unfolding over time. Flushing, and here's the curious thing, galaxies themselves don't expand. Stars don't drift apart, atoms don't grow, gravity holds those structures together. It's only on the largest scales, between clusters of galaxies, that expansion dominates. Inside a galaxy, the stars remain tethered. Inside a solar system, the planets still orbit in calm, familiar rhythms. Flaming isn't something you can feel. You don't wake up slightly further from your pillow each morning. But across billions of light years, that gentle stretch becomes profound. Turbulence. In fact, some galaxies are already moving away from us faster than the speed of light. Not because they're breaking any laws, but because the space between us is growing that quickly. Their light will never reach us. They've crossed a kind of cosmic horizon, not by moving, but by drifting beyond the grasp of even light's long fingers. That idea is both humbling and peaceful. Breached, it means there are things we'll never see, not because they're hidden, but because the universe is too large and too slow to show them to us in time. It means the night sky is not a snapshot, but a slow river, always flowing, always pulling some things gently out of view. Ours overhead still shine, the galaxies we can see are still telling their stories. Expansion doesn't erase beauty, it just stretches the silence around it. So tonight, if your thoughts begin to wander, let them drift outward, not in a line, but in all directions at once. Imagine space itself breathing slowly and visibly around you. No centre, no edge, just a calm, steady widening. A universe that grows not because it must, but because it can. It's a tempting thought that somewhere deep in the dark there might be a centre, a heart of the universe, a place from which everything began, and toward which everything else might point. We like centres. They make sense to us. Our cities have centres. Our stories have beginnings. Our lives revolve around focal points, homes, hearths, people. So it's only natural to wonder, where is the centre of the universe? But the icingly is this: there isn't one. Or rather, everywhere is the centre, including where you are right now. Poetry is a result of decades of careful observation and the quiet brilliance of what's called the Copernican principle, the idea that we do not occupy a privileged place in the cosmos. With Copernicus, who moved Earth from the centre of everything to just another planet orbiting the Sun. That shift, subtle in theory, seismic in meaning, echoes through cosmology even today. We've learned again and again that the universe doesn't revolve around us, and yet it includes us. In an expanding universe, with no fixed background, there is no central location from which the cosmos unfolds. Instead, space itself expands uniformly in every direction. No matter where you are, on Earth or in a galaxy billions of light years away, you would observe the same thing: galaxies drifting apart, space stretching, horizons slipping away. Not that there's no structure, there is. But the expansion is not like a firework bursting from a point. It's like a loaf of bread rising, with every raisin moving away from every other raisin. No raisin is more central than any other. All experience the same swelling silence. So when people ask where the Big Bang happened, the answer is quietly astonishing. Everywhere. It wasn't an explosion in space. It was the beginning of space. Time, space, energy, all beginning not in a spot, but in a state that expanded. Schizophrene, that's okay. The universe is under no obligation to match our instincts. But here's something gentle to hold on to. Just because the universe has no centre, doesn't mean you aren't centred in it. You are the centre of your observable universe. That light bubble we spoke of earlier, it is centred on you. Every other observer in the cosmos has their own equally valid view. No one sees the whole, no one owns the origin. And in that way, there's something beautifully democratic about the cosmos. Ubisoft so single place is more real than another. No one's view is more true. We are all embedded in the same fabric, moving with it, drawn by its patterns. No one floats above it, we are part of it, and it is part of us. So tonight, if your thoughts drift toward the centre of things, toward meaning, toward purpose, remember this quiet truth. You don't need to be at the middle of the universe to matter. The stars don't orbit you, and they don't have to. You're already in motion with them. And the view from here, at your own little coordinate in this unfolding cosmos, is as real, as valid, and as filled with wonder as any place could be.
At the edge of our understanding, just beyond the quiet curtain drawn by observation, something curious stirs. Not certainty, but imagination. Not proof, but possibility. What if this universe isn't alone? This is the question at the heart of multiverse theories. Not a single cosmos, but many, countless maybe. Some nearly identical to ours, some wildly different, some stillborn, some impossibly strange. It sounds like science fiction, and for many years that's where it stayed. But, as our models of the early universe became more precise, the door opened just a little. Not because we wanted more universes, but because the equations began to suggest them. Washington comes from inflation theory, the notion that, in the first instant after the Big Bang, the universe expanded faster than the speed of light, smoothing and flattening everything we now see. But inflation may not be a one-time event. It might be eternal. Like bubbles forming in boiling water, each one a separate universe, budding from a greater space. If so, our universe is just one bubble in a vast cosmic foam. And the others? They may exist with different laws of physics, different particles, even different dimensions. Another path to the multiverse winds through quantum mechanics, specifically the idea that every possible outcome of a quantum event actually happens somewhere. In one branch, you turn left. In another, you turn right. In this interpretation, reality itself splits endlessly, branching into an infinite tree of what-ifs. And then there's the idea that black holes might spawn new universes. When a massive star collapses into a black hole, it creates a region where space and time twist into a singularity, a point of infinite density. But some physicists wonder, what if that singularity is not an end, but a beginning? A kind of bud, blooming not in our universe, but into its own. A baby universe, pinched off and expanding in its own direction, beyond our reach. Ideas are not settled science. They live at the edge, where theory stretches into speculation. But they aren't pure fantasy either. They grow from real equations, real models, real effort to understand what happened in those earliest, unreachable moments. Confirm them, they serve a purpose. Unresolved us that the universe doesn't owe us neatness. It doesn't have to stop where we stop seeing. It doesn't need to fit inside the limits of our intuition. In fact, some of the most beautiful ideas in science began as bold guesses. Copernicus, too, once sounded absurd. Prescribe is also a gentle warning here. These are ideas, not destinations, theories, not conclusions. It's okay to explore them, to sketch their outlines in the starlight, but we shouldn't mistake the sketch for the map. Still, there's a quiet thrill in wondering, what if? Grandchildren, if every black hole is a seed? What if universes outnumber stars? What if we're just one echo in a chorus we'll never fully hear? You don't need answers to feel awe. Sometimes, questions are enough. Tonight, as you lie in the stillness of your own universe, one full of atoms, stars and breath, know that beyond even our deepest gaze, the cosmos might go on, and on, and on, in ways stranger, quieter, and more beautiful than we've yet imagined. Not because we see them, but because we dared to ask. We like to think in edges, the edge of a map, the end of a road, the rim of a glass, or the limit of the sky just before it meets the sea. Boundaries help us feel secure. They let us know where something stops and where something else begins. But the universe, softly, stubbornly, refuses to give us that comfort. There is no clear edge out there, no fence around space, no glowing sign that says, "Here it ends." When we speak of cosmic boundaries, we're really speaking of limits to our understanding, of where light stops arriving, of where our models start to blur. And so edges in cosmology are not endings, they are horizons. Rather certainly isn't a wall, it's a point beyond which we simply can't see, yet. Like standing on a beach and looking out across the ocean. The water doesn't stop at the horizon, it only disappears from view. It goes on, but without us. These edges show up in all sorts of places. The event horizon of a black hole, for example,
the point beyond which nothing can escape, not even light. Or the cosmic light horizon beyond which the universe has expanded so much that its light will never reach us. These aren't walls, they're quiet boundaries of experience. And sometimes edges are personal. There's the edge of what we can imagine, the edge of what we can emotionally grasp, numbers too large, timescales too long. We reach for them like fog on a mirror. Our fingers make marks, but the image never quite clears. Is beautiful, because edges invite reflection. They ask us to pause, to feel the quiet pull of humility. In the face of a universe we cannot measure completely, we learn to sit still, to wonder without needing control, to rest in mystery without rushing to close it. While the word universe comes from Latin roots meaning turned into one, as if it were a complete sentence, a finished shape. But more and more it seems the universe is unfinished, not in flaw, but in motion, a sentence still being written, and we are inside it, not on the edge, not at the centre, but somewhere in the middle of the story, looking out. Maybe that's why cosmology so often turns poetic, because when we reach the edges of what we can prove, we don't stop asking, we just ask more quietly. We turn to metaphor, to patience, to awe. We say the universe is curved, or flat, or infinite, but what we often mean is, we're still listening, still catching pieces of a song too large for one voice. We find more questions, that's okay. The sky doesn't need to answer us. It only needs to be. So tonight, as you rest, let go of the idea of edges as endings. Let them soften. Let them stretch. Imagine the universe not as a container, but as a current. Wide, deep, and gently unfinished.
There's a quiet strangeness in trying to think about everything. To stretch your mind across billions of years, through galaxies, through expanding space, through forces you can't see. To imagine stars being born and dying while you're brushing your teeth. To consider that somewhere, in the soft dark of a nebula, a new solar system is forming while you check your phone. And yet you can hold both, the universe and your life. Not as opposites, but as layers of the same story. Crimson, there's a moment that happens sometimes, when you look up at the night sky, maybe during a walk, maybe through a telescope, or maybe while just lying on your back in the grass. A moment when your thoughts drift outward and upward, past the clouds, past the atmosphere, past even the stars. And then a quiet feeling arrives. You realise that everything you've ever touched, seen or known is happening on a tiny world, spinning around an average star, in a galaxy that's just one among trillions. You realise how small we are. As quietly something else happens. You don't feel smaller. You feel included. Because here's the gentle truth. Your awareness of the universe is not separate from it. You are part of what it's doing. You are made of its elements, shaped by its laws, carried by its forces, and now you're reflecting on it, thinking about it. You, a collection of molecules and memory, are noticing the whole. That's not a contradiction. Prominence, it's a kind of harmony. Yes, the universe is immense, far beyond human scale, but that doesn't make human scale less real. The warmth of a hand in yours, the smell of rain on pavement, the sound of your own breathing in the quiet morning. These are real too, and they matter, not in spite of the cosmos, but within it. You're not outside the universe, looking in. You're inside it completely. You're a node in the net, a ripple in the current. You don't just observe the universe, you participate in it. And here's something gentle to remember. The atoms in your body once came from stars. Real stars. They lived, they burned, they died. They scattered their elements into space. And eventually those elements found each other again, formed new systems, new planets, one of which is spinning under your feet right now. Butterflies are not a footnote in the universe's story. You are a full sentence. So how do we hold both scales at once? The answer is simple. We already do. Every day. You get groceries under the same sky that holds Andromeda.
You wake up and check the weather on a planet orbiting a star, drifting through a spiral galaxy, in a local group of galaxies moving through a supercluster. And yet, you still make tea. You still laugh. You still feel heartbreak. You still hope. Cosmic and the ordinary are not separate rooms. They are windows looking in on the same scene. Tonight, as you let your breath slow and your thoughts settle, know that it's okay to marvel at vastness and then turn back to your own soft, ordinary life. They are both real, they are both true, and you belong to both.
Let's imagine you're writing a letter. Not an email, a quiet, handwritten letter, folded with care, sealed, stamped. Knocking buttons is one's a little different. It's addressed to you. You write your name, then your street, then your city, your country. So far, everything feels familiar, local, manageable. But now, let's keep going. A small, rocky world wrapped in air and water. Home to forests and cities and microbes and cats. Floating in space like a blue marble with weather. Earth orbits a star. Not the biggest, not the smallest. A G-type main sequence star we call the Sun. Warm enough, steady. It sits near the edge of a spiral arm of the Milky Way galaxy. A vast swirl of stars, gas, dust, and dark matter. That's your galactic neighbourhood. But the address doesn't stop there. The Milky Way belongs to a group, a gravitational gathering of more than 50 galaxies called the Local Group. It includes our largest neighbour, Andromeda, and dozens of smaller companions like the Magellanic Clouds, quietly glowing in the southern sky. The Local Group is part of a larger structure, the Virgo supercluster, an immense, loosely bound collection of galaxy clusters, each one like a city of galaxies with voids and filaments threading through them. And that supercluster? It's not the top of the ladder either. In 2014, astronomers gave our corner of the cosmos a name, Laniakea. It means immense heaven in Hawaiian. A poetic map of more than 100,000 galaxies, all moving together, bound by gravity, like leaves floating in a slowly turning stream. So your cosmic address, written from smallest to largest, might look something like this. Flutter, your street address. Nelm, your city. Your country. Planet Earth. Solar System. Orion Arm. Milky Way Galaxy. Local Group. Propelled Virgo Supercluster. Distinguishing Laniakea Supercluster. Observable Universe. And here's the beautiful thing. No matter where you go in this address, down to your street or out to the stars, you are still you. Constant in the layers, present in every line. I already stayed, what and mini. You, in your address. You've never touched a galaxy or held starlight in your hands. You've never flown past Jupiter or caught a particle of the cosmic microwave background in your palm. And yet you've seen them. You've seen Saturn's rings, delicate and pale. You've seen spiral galaxies like frozen whirlpools. You've seen red-shifted specks at the edge of the observable universe, all through instruments, gentle extensions of the human senses, telescopes, sensors, detectors, algorithms, and also dreams. When Galileo first raised a telescope to the sky in 1609,
It wasn't a scientific revolution yet. It was curiosity. He turned a tube of curved glass toward the moon and found mountains, toward Jupiter and found moons. He didn't just see light, he saw motion. He saw that the heavens moved, that they had depth. Centuries later, we still build tools to stretch our sight. Radio telescopes the size of football fields, mirrors that cool themselves to near absolute zero, orbiting observatories like Hubble and Webb that hover above the blur of Earth's atmosphere. These instruments don't just take pictures, they collect truths. They gather photons that left their source billions of years ago. They split those photons into spectra, revealing a galaxy's speed, its chemical makeup, its temperature. They detect gravitational waves, ripples in space-time itself, caused by black holes colliding far beyond our vision. Aren't limited to machines. Your mind is an instrument too. Position to imagination, to build to imagine, to build models, to see the invisible, to hold vastness in thought. That's a form of observation. The first questions about the stars weren't asked by physicists. They were whispered by shepherds, travellers, poets. Wonder came first. The math came later. Blinked computers to simulate galaxies. We write code that lets us recreate supernovae. We launch robotic probes to scan moons for ice. And all of that began because someone, somewhere, looked up and thought, what is that? That question is an engine. It powers every lens we grind, every sensor we build, every satellite we send beyond the clouds. And it powers something even older. Hope. The hope that knowledge makes things brighter. That understanding helps us not just reach farther, but come closer. To each other. To meaning. To peace. Blackmail. In a world so often distracted and divided, the sky remains one of the few things we still share. No matter where you are or who you are, the stars don't change their path for you or against you. They just shine, unfinished, and we watch, and we wonder. Ever build a telescope or analyze a signal from a distant star? But every time you allow yourself to ask, what's out there? You are part of the same moment to listen. The universe is still speaking. And through tools made of metal and mirrors and thought, we are still learning how to hear it. Not every instinct helps you survive. Curiosity doesn't feed you, wonder doesn't shelter you, awe won't chase away a predator. And yet, they remain. Strong, persistent, ancient. You might not notice it often, but you carry within you an ability not just to see, but to feel wonder. That subtle widening of your attention when you gaze at the stars. That pause, deep and quiet when you hear something vast in the silence. This isn't an accident. It may not be essential to survival the way hunger or pain is, but it's essential to something more delicate. Meaning. Combating from an evolutionary perspective, some researchers think awe evolved to help us cooperate. When early humans stood together and looked up at storms or mountains or the night sky, they felt small, and in feeling small they also felt together. Awe helped shift focus from me to we, from control to connection, what helped us thrive. But awe does more than bind us to others. It also binds us to the world. When you feel wonder, your mind becomes quiet. Time slows. You're no longer racing to the next task, the next appointment, the next thing. You are simply here, breathing in something vast and letting it settle into your bones. You don't need a telescope for this. You don't need numbers or names. You just need to look, really look, at a sky full of stars, or a single tree lit by moonlight, or even the reflection of twilight in a puddle on the sidewalk. Awe lives in small places too. Flooring if you've seen the stars 1,000 times, some nights they hit differently. Maybe because of the cold in the air, or because of something you can't quite name. Maybe because in that moment, you remember how quiet the universe can be, and how rare it is to be awake inside it. Awe doesn't demand anything from you. It doesn't ask you to explain or solve. It simply asks you to notice. And in noticing, something shifts, not just in your mind, but in your body. Studies show that feelings of wonder can reduce stress, lower inflammation, increase compassion, even expand your sense of time. You feel that that's strange. The bigger the universe gets, the less rushed you feel. Perhaps that's the gift of the night sky. Not answers, but spaciousness. In a world filled with distractions, awe can be a form of rest, a way of remembering that not everything urgent is important, and not everything important is loud, flaming you. So if you ever find yourself tired, or uncertain, or quietly aching for something more, try this: open a window, step outside, look up, or out, or just pause. Let your eyes adjust, let your breath slow, and see what's always been there.
You've travelled far tonight, from the soft pull of Earth's gravity to the spiralling dance of galaxies, through nebulae and ice moons, exoplanets and black holes. You've crossed light years without lifting your head from the pillow, drifting quietly on waves of thought and photons older than language. But maybe, now that you're here, the real question is, why does it matter? Why spend time wondering about things you'll never touch? Why drift so far into the stars when life down here is already full of tasks, of people, of mornings that arrive too early? The answer isn't loud. It doesn't come with a conclusion or a grand revelation. It arrives the same way a star appears at dusk, softly, gradually, almost as if it had always been there. This journey matters because it reminds you of something easy to forget, that you are part of something wide and ancient, and it doesn't need to be explained to be beautiful. In a world that often demands productivity, certainty, speed, this kind of quiet attention is its own kind of rebellion. To pause, to wonder, to feel curiosity not as a task, but as a comfort. You're not here to memorize facts or to prove anything. You're here because looking outward can sometimes help you feel inward. Because thinking about galaxies and dark matter and the glow of ancient light somehow makes space for your own stillness. The universe isn't a riddle to solve. It's a presence to rest within. And curiosity, the kind that brought you here tonight, is not just a way of gathering knowledge, it's a way of sharing experience. You are not the first to ask these questions, or the only one. You're part of a long, quiet line of people who looked up and asked, "What's out there?" And, quietly, "What does it mean that I'm here to ask it?" This shared wondering stretches across time, across cultures, across every hilltop where someone has tilted their head back to feel small and whole and included. So when you think of this journey, not as a lecture or a lesson, but as a gentle walk together, you begin to understand why it matters. Because sometimes, to feel less alone, you don't need noise, you don't need answers, you just need a little space, and someone to walk through it with you. So here we are, wondering, still quietly amazed. Let's take one last look back, not to retrace every step, but to feel the weight of the whole journey. Like watching the sunrise on a trail you walked in the dark, letting the memory of distance settle into your shoulders with a kind of peace. We began at home. You felt gravity beneath your feet, not as something heavy, but as an anchor. The soft pull that holds you close to Earth. And then slowly, you let go, rising with rockets, slipping gently through the layers of atmosphere, lifting off not with force, but with wonder. You reached orbit, the floating toothbrush, the tortilla, chosen not for flavour, but for function. Tiny choices in a world without weight, a place where sleeping means drifting, and waking means watching the world turn below again and again. From that altitude you saw Earth, blue, glowing, impossibly fragile. Sunrises every 90 minutes, storms as spirals, borders vanished. Home became round and delicate. Then, outward. You visited the moon, where shadows are sharp and footsteps still sit in silence. You wandered the scorched face of Mercury,
the cloud-smothered greenhouse of Venus, and the rusted whispers of ancient rivers on Mars. You rode alongside robots, tiny ambassadors crossing dust and distance on our behalf. You drifted through the asteroid belt, among rocks that never became planets, and then, past the giants, Jupiter's storms, Saturn's rings, Uranus and Neptune, pale and distant. You paused at Pluto, not a planet anymore but still full of story, and followed new horizons, into the edge of the sun's influence. But not empty. He entered the galaxy, a spiral arm of stars and gas and gravity. You saw the Milky Way not just as sky, but as structure, a swirl you live inside without noticing. You met its neighbours, Andromeda, the Magellanic Clouds, and felt the slow approach of cosmic embrace, galaxies moving toward one another like dancers seen across a frozen lake. And beyond those clusters came the threads, the cosmic web, galaxies in filaments, drifting through dark matter scaffolding. You saw voids wide enough to hold 1,000 galaxies, and light stretched thin by expansion. You glimpsed the Hubble Deep Field, an image of the empty sky filled with ancient light. You stood beside the James Webb Telescope, catching the warmth of the first stars. You asked about edges, and the universe answered with silence. Explosions, that the observable universe isn't everything. It's just what light has had time to reach us. That we see the past, always, in every direction. That the oldest light, the cosmic microwave background, still hums around you now. Disproportionate of the idea of a centre, you wondered about multiverses. You sat with unknowing, and instead of recoiling, you rested. Rested. Stabilized. None back to the beginning, but inward, to yourself. You remember
That your street has a cosmic address. That your breath contains atoms forged in stars. That wonder isn't a luxury, but a way of living gently in a vast and wild universe. This wasn't a race. It wasn't a test. It was just a walk. A soft wandering. And now, with the trail behind you and the stars above you, you can pause. Not at the end of the story, for Rudgoh, just at a still moment in the middle of it. There's a softness in not knowing. We're taught, often, that questions are ladders, that if we climb high enough step by careful step, we'll reach an answer, a summit, a final page. But some questions don't close like books. They stay open, like windows at night, letting in the cool air and the distant sound of something moving through the dark. The universe is full of such questions. What lies beyond the observable edge? Why does anything exist at all? How did the laws of physics take shape? Are there other universes, other beginnings, other versions of us threading through time in quiet parallel? Science, with all its rigour and brilliance, reaches far. It maps, predicts, decodes. It builds instruments that capture starlight and equations that trace the patterns of galaxies. But even science, in its deepest corners, learns to whisper. You go into the cosmos, the less certain things become. It's a gift. To not know is not the same as being lost. Sometimes, not knowing means being present. It means accepting that you are part of something vast and unfinished, and that you do not need to solve it to belong in it. Breaking doesn't have to be a puzzle. Sometimes it's just a place to rest. You can stretch out under a sky full of stars without understanding how fusion works. You can gaze at the moon without calculating its orbit. You can feel awe, not because you've mastered the math, but because the math leads into silence, and you are allowed to stay there. There is peace in letting some things remain open. Position of the universe, the fate of dark energy, the shape of time. These aren't problems to be rushed. They are quiet paths through the forest, and it's okay to walk them without reaching the end. There is a kind of humility in cosmology, a kind of gentleness. It reminds us that we are not the authors of the universe. We are readers, listeners, momentary observers watching the light pass by. Plunge, we have everything we need, while your joy of discovery, the weight of mystery, the soft breath of understanding, followed always by another question. So if tonight your thoughts begin to drift into the infinite, or just into the dark behind your eyelids, let them go. Let the unanswered things remain unanswered. Let the edges stay misty. Let the unknown be a pillow, not a pressure. Premature the universe is not waiting for you to fix it. It is simply there, unfolding. You. There's a moment, just before sleep, when everything begins to drift. Thoughts loosen. Time softens. The boundary between yourself and the world around you begins to blur, like fog rolling in over a still lake. You don't fall asleep all at once. You slip. You surrender. And maybe that's the most beautiful echo of the universe yet. Because you too are made of stardust. You too drift through space, orbiting a sun, spinning through a galaxy, floating in the darkness. Every cell in your body knows motion. Every atom was once part of something older. Asleep. You're not leaving anything behind. You're rejoining it. The stars don't blink out when you close your eyes. They go on shining in their quiet way. Galaxies keep turning, moons keep orbiting, and your body, small and miraculous, enters a kind of trust, a pause in awareness, a rest. Imprisoned is not absence, it's a return to stillness, to safety, to the quiet rhythm of a mind allowed to wander without needing direction. Tonight, you've wandered far. From the tug of gravity at your feet to the delicate swirl of superclusters, from space stations to Saturn's rings, from black holes to the deep hush of unknowing. And now, it's time to stop walking, pragmatic, to float, gasoline, no more answers, no more questions, just the soft weight of a blanket, the hush of a room grown still, the steady pull of your breath like a tide that knows its way home. Let your body sink. Let your thoughts unspool. Let go of the need to reach or name or remember. There is nothing you must do now. Plumbing is not waiting. It is not judging. It does not measure your worth in productivity or understanding or certainty. It simply includes you. Blake. Tamond. You can rest not because you've figured everything out, but because you've let yourself feel something vast. And that is enough. Money, stars, go quiet. Let the galaxies blur. Let the questions fade like footprints in snow. You are safe. Position. You are small. And that smallness is not insignificance. It is belonging. Shall well, wanderer. Peacefully. We'll still be here.